Uh, Good afternoon, friends. So today we are again here to have a look at another topic. The topic of the day is permutations and combinations, and I suppose you have already studied it in your 11th class. And today, therefore, because you already have a fair idea of this particular topic, I will start almost directly with the questions, but still giving a brief introduction of the topic, and we will like to understand a certain concepts through questions only. As I told you that today's topic is permutations and combinations. It is all about arrangements. If it is about counting of numbers, how do we count numbers? Let us see. There are some principles of counting. We call them fundamental principles of counting. Suppose there are two jobs and we have to perform both of them. But the sequence is that we first perform the first job, then we take up the second job. And if the first job can be performed in m ways, second in n ways, the two jobs together can be performed in m cross n ways. Let us see an example. Suppose this is also known as principle of multiplication. Let us see the next. Let us take this question. A class has got 20 girls and 18 boys. In how many ways we can choose a boy and a girl to represent the class? Maybe we are going to have two monitors in the class. So one girl out of 20 can be selected in 20 ways, and one boy out of 18 can be selected in 18 ways. So the total number of representations of a girl and a boy will be 20 multiplied by 18. That means 360 representations can be there. But in the other case, when we have the next principle, which is principle of addition, here you can see what we have written here is, if there are two jobs or tasks which can be performed independently in m and n ways respectively. That means there are two jobs, they are independent of each other. One can perform one job, one can perform another job simultaneously. But what we want is either of the two jobs has to be done. Then the total number of ways is m plus n. This is equivalent to the last problem in this way. If we see the next problem, if there are 18 boys, just show me the next slide. Now the here principle of addition says if there are 20 girls and 18 boys, and we want to select one of the students as monitor. So one girl we have either to select a boy or a girl. So one girl out of 20 can be selected in 20 ways. Similarly, one boy out of 18 can be selected in 18 ways. So choosing either a girl or a boy becomes 20 plus 18, that is 36. That is simple. Let us see the next slide. So let us try to apply now these principles of counting in practical questions. The first question says a room has 5 doors. In how many ways can a person enter the room and exit from another door? The person has to enter the room from one door and exit from another door. If I number the doors as 1, 2, 3, 4, 5. Suppose the person enters to 1, he is not permitted to exit from 1. So how many choices are there for entering? He can enter from any one of the doors. So there are 5 possibilities of entering. So how many possibilities are there for exiting? 4. Because if he has entered from door number 1, he cannot exit from door number 1. So the choices are 4. So 5 into 4, there are 20 choices. So this is and application of the principle of multiplication. Now, what were the two jobs? Entering through one door and exiting from a door different from the door from where you entered. If we had not put this restriction, the choices would have been 25. One can enter from any one of the 5 doors and can exit from any one of the 5 doors. So there will be 25 choices. The next question is, how many different signals of 3 colored flags can be generated if we have 7 flags of different colors? So we have got 7 flags which are different in color. We want to generate a signal which consists of 3 colored flags. That what it means is red, blue, yellow may mean one signal. Suppose we are talking in terms of some codes, and blue, white, and green may have some other. So how many different signals can we generate? Now you can see this problem like this, that there are 1, 2, 3 places, because the signal is to have 3 flags. So one flag is here, one flag is here, one flag is here. How many choices are there for this? 7 choices. Here 6 choices, and here 5 choices. So we have 210 choices. Here we have not said whether the flags are to be repeated or not. But since we have only 7 flags and they are of different colors, suppose we have used the white flag, we cannot use it again. So we are left with 6 flags. So sometimes it is automatically understood from the question whether we have to repeat the thing, repetition is allowed or not allowed. Okay, so here we can multiply and see. Let us see what is there in the next. How many, this question says, how many 4-letter words can be formed using the English alphabet if repetition is permitted, if repetition is not permitted? English alphabet means 26, A to Z. There are 26 letters. So if we are supposed to form a 4-letter word. 4-letter word means there are 4 places. They have to be filled with 26 letters. So first place has choices. How many? 26. If we are permitting repetitions of letters, there will be 26 into 26 into 26 into 26. So many choices. And if we are not permitting repetitions, there will be 26 into 25 into 24 into 23. So many choices. That is pretty simple. Let's see the slide again. Let's go to the next question. It says how many sequences of possible answers are there if an objective type question paper has 10 questions and each question has 4 choices. You are familiar with objective type questions. A question is given and below the question there are a number of choices. Suppose every question has 4 choices. What do we mean by the sequence of possible answers? That different students will answer them differently. That means if we want to collect that all students, what different possible ways can a student answer them? Suppose first question का answer दिया A, second का दिया B, C का दिया 3 का दिया C, and so on. So there are different sequences. ये भी किया जा सकता है कि फर्स्ट का C मार्क कर दें हम और 2 का कुछ और कर दें, 3 का डिफरेंट चॉइस. हम सारे पॉसिबल सीक्वेंसेस गिनना चाहते हैं. अब इसमें थोड़ा परमुटेशन और कॉम्बिनेशन में हमें सब्जेक्ट की स्पिरिट को समझना और लॉजिक समझना कि हम कैसे अटेम्प्ट करेंगे. फॉर्मूले आर देयर, बट फॉर्मूले विल हेल्प यू ओनली इफ यू हैव absorb the concepts very deeply. Now here the problem is that there are 1, 2, 3, 4 choices and there are 10 questions. Let us see from here. This choice A, this can be for any one of the 10 questions. Here again 10 questions. Let us start from there. Question number 1, how many choices are there? 4. Question number 2, 4 choices. Question number 3, question number 4. So how many questions are there? So there is 4 raised to power 10. Anybody answering the question paper can answer 1A, 1B, 1C, 1D. That means there are 4 choices for question number 1. Similarly, for question number 10, there are 4 choices and so on in between. So 4 raised to power 10 are the possibilities. How much is this number? You guess? It's very big. What is 2 raised to power 10? 1024. What will be 4 raised to power 10? 1024 into 1024. It's a big number. Anyhow, let's go to the next problem. Suppose there is a set of 6 questions and every question has to be answered in terms of true and false. So every question has got 2 choices. So what are the choices for answering all the 6 questions? All possible sequences? 2 to the power 6. But here the question is not just this. We have fixed up certain conditions. It says no 2 students gave the same set of answers. क्योंकि 6 क्वेश्चंस हैं, 6 क्वेश्चंस के अगर किसी स्टूडेंट ने पहले 3 ट्रू बताए हैं और अगले 3 फॉल्स बताए हैं तो किसी और स्टूडेंट ने ऐसा नहीं किया, यानी सब स्टूडेंट्स के आंसर्स अलग अलग हैं. दिस इज व्हाट इज मेंट बाय no 2 students gave the same set of answers. And what does the second condition imply? No student has written all the correct answers. तो मान लो कोई एक पर्टिकुलर सीक्वेंस करेक्ट था, वो किसी ने नहीं लिखा. टोटल कितने सीक्वेंस बनते हैं हमारे पास? 64. इनमें से एक सीक्वेंस होगा जो करेक्ट आंसर्स का होगा, वो किसी ने नहीं लिखा, और किसी भी 2 स्टूडेंट्स ने सेम नहीं लिखा. इसका मतलब हमारे टोटल नंबर ऑफ स्टूडेंट्स कितने हैं ये देखना हमें. टोटल चॉइसेस कितनी है? 2 raised to power 6. व्हाट इज दैट नंबर इक्वल टू 64. इन 64 चॉइसेस में एक चॉइस है जिसमें सारे आंसर्स करेक्ट हैं. उसको अगर हम छोड़ दें तो ये कितनी चॉइसेस हो गई? 63. इसका मतलब हर स्टूडेंट ने क्योंकि अलग अलग चॉइस दी है, उसके लिए 63 स्टूडेंट्स होने चाहिए. ना 63 से ज्यादा हो सकते हैं ना 63 से कम हो सकते हैं, क्योंकि सबने अलग अलग आंसर किए हैं. और 64 होते तो नेक्स्ट चॉइस भी होती, और 65 मान लीजिए कोई कहे हैं तो 65 स्टूडेंट ने क्या किया होगा? कोई चॉइस रिपीट की होगी, तो हमारे पास एग्जैक्टली 63 स्टूडेंट. तो ये क्वेश्चन तो बिल्कुल सिंपल है, लेकिन थोड़ा इनडायरेक्ट है. हमें नंबर ऑफ स्टूडेंट्स ना देकर हमें नंबर ऑफ स्टूडेंट्स कैलकुलेट करने थे फ्रॉम द गिवन कंडीशन. इज दैट क्लियर टू यू? लेट्स सी अनदर प्रॉब्लम. So now I am attempting to solve certain problems without any knowledge of the formula NPR or NCR. And if you can adapt to that, that is the best option. But of course, you need to know formula and learn them properly, because certain problems, as you will see later, are dependent on formula. It says how many 3-digit numbers can be formed using the digits 2, 3, 4, 5, 6 if repetition is not allowed. First of all, can you tell me how many 3-digit numbers are there? What is the first 3-digit number? First 3-digit number? 100. What is the last 3-digit number? 99. So how many are there? Oh, starting from 100 to 999. How will you find out how many are numbers? They are 900. They are 900 because you have to subtract this number 199. If you subtract from 999, the first 99 numbers which contain 1-digit numbers and 2-digit number, you get 3-digit numbers. So there are 900 3-digit numbers, but what we are interested in finding out, how many 3-digit numbers can be formed using 2, 3, 4, 5, 6. We are not using how many digits are there, with the help of which we find, we write numbers. Total digits कितने हैं हमारे पास जिनसे हम नंबर बनाते हैं? 9, 9, 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 digits. और 10 digits को जितने मर्जी इस्तेमाल करें तो कितने बनते हैं? इनफाइनाइट बनते हैं, क्योंकि नेचुरल नंबर्स इनफाइनाइट हैं. आप किसी भी नंबर को कितना भी बड़ा नंबर लें, सिर्फ इन 9 और एक 0 10 डिजिट्स की हेल्प से बना सकते हैं. Let me rub it off so that you can see clearly. Now, the digits we have are 2, 3, 4, 5, and 6. And how many places we have to fill in? 3 places. So, how many choices are there for the first place? 5. You can either put 3 or 4 or 5 or 6 or 2, any one of them. If repetition is not allowed, how many? 4. How many? 3. So there are 60 choices. So this is repetition not allowed. Not allowed. And if you permit repetitions permitted, there are 5 choices for the first place, 5 for the second, 5 for the third. So there are 125 choices in all. Okay, let's see the next slide. Oh, please, same slide, sorry. How many of them are greater than 700? The digits are 2, 3, 4, 5, 6. You cannot form any, this number is 0. How many of them are greater than 600? If you have to write a number greater than 600, that first is fixed. That number should start from 6. So the first place, I mean hundreds place, has got only one choice. It must start with 6. And if you are not bothering about repetitions are permitted, तो आप यहाँ पर फिर कितने रख सकते हैं? Any 5 of them, 5 choices, and here also 5 choices. So you can write 25 numbers. Can you list them? Go home and list them. Let us see if repetitions are not permitted. That means you have written 6 here. How many choices are there? Because 6 हो गया. और बाकी कितने बचे हैं? 2, 3, 4, 5 में से there are 4 choices and then there are 3 choices. So you can have 12 choices. So similarly, you can attempt problems concerning 4 digits, 5 digits, etc. So this is a class of problems you must very well understand. Now we see the next slide where we have to form a password. It says how many passwords to an email account are possible if the password is supposed to have 5 letters from the English alphabet followed by 3 digits. English alphabet के कोई भी 5 letters और उसके बाद 3 letters कोई भी digits. तो हमारे पास total 8 places हैं. This is already fixed that first 5 places have to be filled by alphabet. I mean letters from the alphabet, and next 3 are digits. So there are 26 choices here and 10 choices here from which we have to fill up the numbers. Because for passwords, nobody says that you don't have to repeat. You can repeat. In particular, this you are using from your knowledge that how is a password created. If it is specifically mentioned that no repetition has to be there, we'll deal with the case accordingly. But here, because we know that in a password, we are allowed to repeat letters. So there will be 26 choices for this, 26 for this, 26 for this, 26 for this, 26 for this. And 10, 10, 10. This number, what is this? You can't calculate immediately, but it's going to be a big number. That's why normally they ask you to have a password of a minimum length. अगर सिर्फ 2 लेटर के 2 डिजिट्स वाले पासवर्ड कहें तो दैट विल बी इजियर टू क्रैक. 2 के कितनी चॉइसेस बनती? सपोज ओनली 2 प्लेसेस वर देयर. एक को सपोज हमने इससे रिप्लेस करना है और एक को इससे. मान लीजिए आपको ये कहा जाए कि आपको 2 लेंथ के पासवर्ड्स बनाने हैं जिसमें से पहला डिजिट एक अल्फाबेट में से चूज करना है, लेटर होना चाहिए, और दूसरा डिजिट. मान लीजिए ये चॉइस नहीं भी रखते, ये रखते कि आप अल्फाबेट और डिजिट कुछ भी रख सकते हैं, तो भी इसके लिए कितनी चॉइसेस हो जाती? 36. क्योंकि हमारे 26 अल्फाबेट हैं और 10 डिजिट्स हैं. टोटल हमारे पास 36 ऑब्जेक्ट्स हैं जिनमें से आप कोई भी चूज करके रख सकते हैं. तो पहले के लिए 36 चॉइस, दूसरे के लिए भी 36 चॉइस. तो ये नंबर बहुत बड़ा नहीं होता, शायद 1296 होता है, 36 का स्क्वायर जो भी होता है. तो 1296 चॉइसेस में से कोई हैकर आपके 1296 में से बहुत आसानी से चूज कर सकता है, लेकिन इसमें से इट्स वेरी डिफिकल्ट. मोर ओवर, आपके पासवर्ड्स में ये कंडीशन नॉर्मली नहीं होती कि पहले सारे अल्फाबेट लिखने हैं और बाद में सारे लेटर्स लिखने हैं. तो अगर 8 डिजिट की चॉइस करनी हो, हमने 8 लेंथ का एक पासवर्ड बनाना हो जिसमें हम डिजिट्स भी रख सकते हैं और लेटर्स भी रख सकते हैं, तो 36 चॉइसेस हर प्लेस के लिए हो गई. रेपिटेशन परमिटेड है, तो 36 into 36 into 36, दैट मींस 36 रेज टू पावर 8 हो गया. और यही क्यों, आपको बाकी सिंबल्स भी तो परमिटेड है. अगर आप कीबोर्ड पे जितने सिंबल्स मिलते हैं सबको डालने की वो रखेंगे तो हो सकता है आपको हर प्लेस के लिए 50 चॉइसेस मिल जाए. आप एक्सक्लेमेशन साइन भी डाल सकते हैं और भी सिंबल्स हैश डाल सकते हैं, @ डाल सकते हैं. अगर ये सारी चीजें आपको परमिटेड हो तो आपकी चॉइसेस बहुत ज्यादा बढ़ जाएगी और इसकी वजह से किसी के लिए भी उसको क्रैक करना और मुश्किल हो जाएगा. दैट्स व्हाई नॉर्मली all applications ask you to have a big password, and they also tell you whether it is strong or not. That means when the number of passwords from the length you have chosen वो बहुत ज्यादा हो जाता है, नंबर ऑफ पासवर्ड्स जो बनाए जा सकते हैं, तो हम नॉर्मली ये कहते हैं कि स्ट्रांग है, इसको क्रैक करना मुश्किल होगा. चलिए, इसी तरह से एक और प्रॉब्लम देखते हैं. सपोज किसी ने अपने फेसबुक अकाउंट के पासवर्ड्स बनाने हैं. यहाँ पर कंडीशंस क्या है? अच्छा, ये सारे अभी जो मैंने क्वेश्चन लिया ये मल्टीप्लिकेशन के प्रिंसिपल को इन्वॉल्व कर रहा था. पहले के लिए इतने चॉइस हैं, दूसरे के लिए इतने, तो दोनों के मिलाकर इतने हो जाएंगे. और हम अब इसका एक्सटेंशन कर चुके हैं. हम सिर्फ 2 जॉब्स की बात नहीं कर रहे थे, 2 3, अभी हमने 8 जॉब्स इकट्ठी की थी. पहली जॉब क्या थी? पहले लेटर, पहले प्लेस पर कुछ नंबर या डिजिट डालना, फिर दूसरे पर नंबर या डिजिट डालना, एंड सो ऑन. राइट? अब यहाँ पर हम थोड़ा वेरिएशन कर रहे हैं. वो कह रहे हैं कि आपका पासवर्ड 6 से लेकर 8 लेंथ का हो सकता है, और पहले 5 प्लेसेस लेकिन उन्होंने कह दिया कि लेटर्स होने चाहिए और उसके बाद वाले डिजिट्स. तो हम देखते हैं 6 साइज के कितने पासवर्ड बनाए जा सकते हैं. उसमें 6 प्लेसेस होंगे, लेकिन एक रिस्ट्रिक्शन है, क्योंकि पहले 5 प्लेसेस पर हमने डिजिट्स रखने हैं, लेटर्स रखने हैं. तो 26 into 26 into 26, दैट मींस 26 रेज टू पावर 5 चॉइसेस हो गई. और बाद के 3 एक पर हम, क्योंकि टोटल 6 है ना, अभी हम लेंथ 6 के पासवर्ड्स की बात कर रहे हैं. वी आर टॉकिंग अबाउट passwords of length. Length means the number of places that are to be filled in. We are using how many? 6 digits. पहले 5 के लिए we have the restriction that they have to be letters. The next, there is only one place left. That is to be filled in by a digit. So digits can be 10. What about 7? Now you can easily see 26 raised to power 5 into 10 raised to power 2, because there are 7 places. First 5 places have to be filled up by letters, last 2 places by digits. So there are 10 into 10 choices. So if you have to make a password of length 8, it will be 26 raised to power 5. This is the number. You can see the number is big in fact. But now what is the total? Addition. Because if you are given a choice that you can form a password of size 6 or 7 or 8, somebody will decide to choose a password of length 6, somebody will choose a length of 7, and somebody may choose length 8. So we have to add all those cases. See, either this or this or this. So now there, because it's a principle of addition. So this number added to this number, added to this number, this is the number of passwords you can generate. I hope the idea is clear. We can proceed further. Let's see the next slide. Oh, this is about, now let's formally come to permutations. If you are given say 10 numbers, taking all of them or some of them, if you want to arrange them, that is what we mean by permutation. So what it says is each of the arrangement made by taking some or all of a number of objects is called a permutation. This is clear? Now let us see these 2 small questions that I have posted here. What is the number of permutations of vowels in the English alphabet? How many vowels are there? 5. A, E, I, O, U. So permutations of 5 things. So you can have A, E, I, O, U. But you can have a different arrangement also. This arrangement is different from this arrangement. We can go on writing all the arrangements, because you have already studied this thing, that if there are n things and you are taking all of them, all the things are different, and you are making all possible arrangements, the number is n factorial. So here there are 5 vowels. So 5 factorial are the possible arrangements. You can write them down, all of them. Would you like to try? Not here, at home. Similarly, what is the number of permutations of vowels taken 3 at a time? That means I choose only A, E and I. So A, I, E is another choice. I can start from E and write another arrangement. So, but I have selected A, E, I. I could have selected I, O and U. So first I am selecting 3 letters from AI, from the vowels, and them arranging them. But you know what is the formula here? The formula will be useful, 5P3, because if there are 5 things and out of that you are taking 3 at a time and arranging them, the choice is 5P3. And you know what is 5P3? It is 5 factorial divided by 5 minus 3 factorial. You can calculate this. It is simple, because it would be 2 here, 5 into 4 into 3 into 2 into 1. So you get 60 choices. Calculations you can do, I mean. Let's see. This you already know. When there is a positive integer n and there is a positive integer r less than or equal to n, mind it, r cannot exceed, should not exceed n. There is no idea of 6P11. That seems absurd, not negative. You have to, this means you are trying to take out 11 objects out of 6. That's not possible. We can make it somehow possible if we permit you to repeat them. Suppose there are balls 6 and you are allowed, asked to take 11 draws. You can take one of them, then throw, keep it in, and then you can do it. But normally selecting 11 things out of 6 is not possible. So therefore this condition, this you have here, NPR is defined when R is minimum 0 and maximum 9. R should lie between 0 and n. And the formula is n factorial divided by n minus r factorial. R cannot be negative, n cannot be negative. Both of them have to be positive, and r should not exceed n. It can be equal to n. Let's see. These are some simple results on the next slide. What is the number of permutation taken one at a time? Suppose out of 5. Taking one at a time. Suppose vowels. If you are selecting only one vowel, either A will be there. A का एक ही arrangement है. E का एक arrangement. I, O, U. So total number is 5. By formula also 5 factorial divided by 5 minus 1 factorial, which is 5 factorial divided by 4 factorial. Answer is 5. That's pretty simple. And if you take all of them, 5p5, how much is that? It is 5 factorial divided by 5 minus 5 factorial. 5 factorial divided by 0 factorial. By definition, 0 factorial is taken to be 1. Okay. So when you are taking all the things at a time, there is only one. There are again, that is 5 n factorial. Answer is for n objects, if you choose all of them and want all the arrangements, it will be n factorial. And if you do not choose anything, what I mean is, we have this option also, no? 5p0, because you have said that npr is defined for r is equal to 0 also. So what will be 5p0? Why? Because 5 factorial in the numerator and 5 minus 0 factorial, which is again 5 factorial in the denominator, so you get 1. So these simple things you must always keep in mind. Let us see the next slide. Now coming to combinations. If you can clearly differentiate between combinations and permutations, half of your problem is solved. That means arrangements and selections. What it reads, each of the selection made by taking some or all of a number of objects, irrespective of their arrangements. What it means is, suppose there are 5 cards and on each one of them a vowel is written, A, E, I, O, U. If I take 3 cards, 3 will appear. So what I want to say is, how many sets of alphabets can be there? You can have AEI, you can have AIO, and so on. Now AEI, we don't have to make arrangements, because in sets arrangements are immaterial. If I write 2, 3, 4 or 4, 3, 2, there is no difference between these two sets. Our sets are unordered. एक सेट के अंदर अगर 3 एलिमेंट लिखे हैं ABC, उसको किसी भी ऑर्डर में लिखेंगे एक ही सेट रहेगा. तो सेट्स के ऊपर अच्छे क्वेश्चंस बन सकते हैं. देखते हैं जरा. Suppose the question is, let's divert from what is there. Suppose there is a set consisting of 3 elements. Let me call it A. How many subsets does it have? What is the number of elements in this? 3. 3 एलिमेंट के किसी सेट से कितने सबसेट्स बनते हैं? Let us see. Let us write down 1, 2, 3, 1 2, 1 3, 2 3, 1 2 3. We have written all of them. Answer is 2 raised to power 3. Now the question is simple. If there are 5 sets, how many subsets are there? 2 to the power 5. But what is important, what I'm trying to tell is when we are selecting, trying to form subsets of a given set, we are just selecting some items, not bothering about their arrangements. So this is a question of combinations. Though it is not mentioned that whether you have to find out combinations or permutations. But this is understood from the context. This is okay? And these two questions which I have written here, can we try them now? How many combinations of 3 letters taken 2 at a time? We have the formula, you know, 3C2, it is given by 3 factorial divided by 2 factorial and 3 minus 2 factorial, it is 3. In general, you know that NC, n minus 1 is always n. If in the examination there is a question, what is 11C10? It is going to be 11. 10C11 is meaningless. 10C10 is 1 because NCN is always 1. NCN minus 1 is always n. Let us see the next problem. How many teams of badminton doubles can be formed out of 5 badminton players? Suppose in a school there are 5 badminton players and we want to select a zonal team to be played in matches which are being held at the zonal level. So out of 5, in ways, suppose these are the 5 students sitting here. A team of 2 is selected, A and B, A and C, so on. So 5C2 is the choice. We are not bothering about AB and BA. They form the same team. So 5C2 is the possible choice. This is 10, you can calculate. 5 factorial divided by 2 factorial and 5 minus 2, which is 3 factorial. It comes out to be 10. One way of calculating is 5 4 upon 2 factorial. Have a look at this number 2. Start from 5, just raise 2 factors. 5 and 4 and divided by 2 factorial. Because what is happening? 5 minus 2, which was 3 factorial, will appear, which will get cancelled with this quantity, always. So in the examination, if you are asked what is 60 C3, you can simply write 60 into 59 into 58 divided by 3 factorial. You don't have to calculate everything. Is that okay? But in the same question, if one of the team members is to be designated as captain, then there will be arrangements, you know. You are selecting out of 5 A and B, but then A and B and B and A are different. If one of them is to be designated, A is selected, designated as captain, and B taken as a member, or B designated as captain and A taken as a member. There are 2 different choices. So you will have to apply permutations. So you have to see from the context also sometimes what is required. Let's see some more problems. Okay, this is the formula. You already know it. NCR is n factorial divided by r factorial and n minus r factorial. Here again, that condition should be satisfied. R should be a number not less than 0, not greater than n. It's okay. Let's go to the next slide. Similar problem here. What is the number of combinations taken one at a time? It will be NC1. And what is NC1? It always n because it is n factorial divided by 1 factorial and n minus 1 factorial. Or the logic I told you, start from this and write only 1 factor divided by 1 factorial. It is n. NC1 is always n. And the next question in this was, if we take all of them at the same time, NCN, how much is that? Sure. 3 students are there. All the 3 have to be selected. We don't have to see any arrangements. What was NPN? It was n factorial. What is NCN? It is 1. Okay, let's see the relationship NCR and NPR. Because what I feel is whatever you are studying, the most simplest or the most complicated concept, you must understand all the concept and their interrelationships. NPR is R factorial divided by NCR. Is that okay? Because what was NCR? Let us write. NCR was n factorial divided by r factorial into n minus r factorial. But what was this part? So it be NPR divided by r factorial. So NPR can be written as r factorial multiplied by NCR. So can you answer now the next question on this slide? Which is bigger, NPR or NCR? NPR. Because it is when you multiply NCR by r factorial, in what case will they be equal? Can they be equal also? And when is r factorial 1? Yes. So these two are equal if r factorial is 1 and r factorial is equal to 1 in two cases, when r is 0 and r is 1. Good. Let's go to the next problem. Now, in both the things, in case of permutations formulae and the formula for the finding permutations of certain things and that of combinations, factorial is playing an important role. But this factorial is also important. You can have some good problems using factorial. Let us see some of them. The question here states, what is the LCM of m factorial, n factorial and p factorial? Related to that, it says there are three numbers. Of course, though it has not been, yes, it has been mentioned that they are distinct and positive. Factorial you cannot find for negative numbers. At least we have not defined it. We have defined factorial for any positive integer and for 0. What is 3 by 2 factorial? Not defined. 3 by 2 factorial. 3 by 2 factorial is not defined. You have not defined factorials for fractions. We have defined for positive integers and for 0. So m and m are positive integers and are different. M is not equal to p is not equal to n, and n is not equal to n. And it is found that their LCM is p factorial. तो m, n और p में रिलेशनशिप क्या होगा? नीचे 4 रिलेशन मेंशन है, m फैक्टोरियल, n फैक्टोरियल और p फैक्टोरियल. इन तीनों का जब एलसीएम लिया तो p फैक्टोरियल आया. कैन यू गेस और फाइंड आउट और कैलकुलेट? Let us see with the help of an example. P factorial? Sure, let us see. Suppose you have 2 factorial, 3 factorial and 5 factorial. 2 factorial is 1 into 2. 3 factorial is 1 into 2 into 3. And 5 factorial is product of 1, 2, 3 and up to 5. So definitely it is going to be more. तो जब इन दोनों का एलसीएम लेंगे 3 फैक्टोरियल 5 फैक्टोरियल का, क्योंकि इसके फैक्टर्स ऑलरेडी इसमें इंक्लूडेड हैं, यू विल गेट 5 फैक्टोरियल. तो दो नंबर्स पॉजिटिव उनके फैक्टोरियल उनका एलसीएम लेंगे तो जो नंबर बड़ा है वो वैल्यू आएगी. फैक्टोरियल आप ऐसे ही निकालते हैं ना. फॉर एग्जांपल 36 और 8 का फैक्टोरियल निकालना है तो हम 36 और 8 का एलसीएम निकालना है तो ऐसा नंबर चूज करते हैं जो दोनों का मल्टीपल हो. पर हम थोड़ा सिंपल एग्जांपल लेते हैं. 5 और 10 का एलसीएम क्या होगा? 10, क्योंकि 5 10 को डिवाइड करता है. तो इस लॉजिक से आप देख सकते हैं 2 फैक्टोरियल हमेशा 3 फैक्टोरियल को डिवाइड करेगा, 3 फैक्टोरियल हमेशा 5 फैक्टोरियल को डिवाइड करेगा. इफ m and n are two numbers and m is greater than n, that means n is smaller than n factorial will always divide n factorial. और जो डिवाइड करता है हाँ वो छोटा होगा. जो डिवाइजर है, जो डिविडेंड है, बड़ा नंबर है. दो नंबर्स में जो बड़ा नंबर है और एक छोटा है जो उसको डिवाइड कर रहा है, दोनों का एलसीएम क्या होगा? बड़ा नंबर. तो यहां पर लेकिन इससे हम क्या डिड्यूस कर सकते हैं इन तीनों में से? डी. P M से बड़ा है ये गारंटीड है, P N से बड़ा है ये गारंटीड है, क्योंकि P M और N का LCM P फैक्टोरियल आया है, पर हमें ये गारंटीड नहीं है कि M N से बड़ा होगा या नहीं. We cannot deduce any relationship between और this, और ये भी हमें कहीं से रिड्यूस नहीं होता, राइट. कई बार क्वेश्चंस में ऐसा होगा कि एक से ज्यादा अगर चॉइसेस करेक्ट होती हैं तो आपको बेस्ट आंसर चूज करना होगा. विल सी सच क्वेश्चंस आल्सो. इसमें तो और कोई चॉइस हम सोच ही नहीं सकते. राइट, लेट अस सी द नेक्स्ट क्वेश्चन. There are some good questions on this. This is just an equation which can be solved. It says n plus 2 factorial is equal to 2550 into n factorial. So n plus 2 factorial means n plus 2 multiplied by n plus 1 into n factorial is equal to 2550 into n factorial. I have intentionally not simplified it further because this is also occurring on the right hand side, so it will cancel out. N plus 2 factorial, that is there on the left hand side, is equal to 2500 into n factorial. So what I have done is written n plus 2 factorial as n plus 2 into n plus 1 into n factorial. So that n factorial cancels out with n factorial on the right hand side, and we can solve the equation thus obtained. What is the equation we get? It is, you get n square plus 3n plus 2 equal to 2550. So you can write it as n square plus 3n minus, you can solve it. It's a quadratic equation. That is simple. You will get the answer. But sometimes, can you factorize it? Okay, you will try this. You will try this. Let's not get into this. It's a simple problem. The only thing was how to get a quadratic equation from this. Let us see the next question. Oh, which of them is true? Inequalities are normally difficult to tackle as compared to equalities. But let us see. This question has got 4 choices. Which one of them is true? Whether n actually they are comparing n factorial and n factorial square and 2n factorial. First, second, third. 3 relations between them. Actually, fourth cannot be true. This is sure, because given any 2 numbers, either number 1 will be greater than 2, or it will be smaller, or they will be equal. There is no fourth choice left. So at least we are sure that none of the above is true. And if there is no negative marking and you have to tick one of the questions, tick A, B or C, because that will increase your chances of 4 out of 1, 1 out of 4 and 1 out of 3, which is bigger, 1 out of 3. So even if you do not know, you can try. But I want you to know before you attempt a question. Result कोई याद है ऐसा? Something like this? If not, the good thing is that in all the choices, there are only same 2 quantities are involved, n factorial and 2n. So let us see. Write down what is n factorial square, and let us also write down 2n factorial. N factorial square means 1 into 2 into 3 up to n. Again 1 into 2 into 3 up to n. This is 1 into 2 into 3 up to n. And no, n plus 1, n plus 1, n plus 2, so on to n. 2n factorial is actually product of all numbers, natural numbers starting from 1 up to 2n. So I have intentionally broken up it like this: 1 to 3 up to n, then n plus 1, n plus 2, and so on to n. And here also you have numbers like this. This and this cancels out. I should not write any sign here. I put a star here. What is the relation here? Less than, greater than, or this? Now, can you guess? On this side, we have 1, 2, 3, up to n. On this side, we have n plus 1, n plus 2, 2n. Right hand side will be bigger. Suppose n 6 है तो यहाँ 1 से लेकर 6 तक का प्रोडक्ट है, यहाँ 7 से शुरू हो रहा है, फिर n plus 1 भी 7, 7, 8, 9 up to 12. So definitely this is going to be bigger. So this is general result. As I told you, sometimes if you know the results, that is always good. तो अपने और रिजल्ट ऐसे बैठकर एक दिन याद नहीं किए जा सकते, आप उनको जितना यूज करते रहेंगे आपको ध्यान में रहेंगे और याद रहेंगे. Let us see the question again. So the first choice is correct, right? Let us go to the next slide. Factorial notation. It is again a use of the factorial notation. 7 factorial plus 1. Is it divisible by 6? Is it divisible by 7? Is it divisible by 5? The answer you have to tell. Now, you can try. You can find out 7 factorial and do it. But the question may be 56 factorial. What to do then? So sometimes, if you know the results, that is always good. And I have jotted down the result on the next slide. The result is n factorial plus 1 cannot be divisible by any number between 2 and n. n factorial 1 से तो divide होगा ही. Every natural number is divisible by 1. पर हम क्या कह रहे हैं, n factorial 2 से divide नहीं हो सकता, 3 से divide नहीं हो सकता, n तक किसी number से divide नहीं हो सकता. Logic is very simple. हम 7 फैक्टोरियल का ही केस ले लेते हैं. 7 फैक्टोरियल प्लस 1 की बात करें अगर, तो 7 फैक्टोरियल क्या होता है, 7 into 6 into 5 into 4 into 3 into 2 into 1. This plus 1. We need not simplify. In fact, simplification के बिना ही रिजल्ट निकलेगा. क्या ये नंबर 2 से डिवाइड होता है? दो नंबर्स का सम है, एक नंबर ये है, एक नंबर ये है. अगर दो नंबर्स का सम 2 से डिवाइड होता है तो दोनों नंबर्स 2 से डिवाइड होने चाहिए. Is that clear? If I say a plus b is divisible by 2, a should be divisible by 2 and b also should be divisible by 2. So this is divisible by 2, but this is not divisible by 2. This is divisible by 3, this is not divisible by 3. And this logic will go up to 7. This is divisible by 7 and this right hand side plus 1, 1 is not divisible by 7. So 2, 3, 4, 5, 6, 7, none of them can divide 7 factorial plus 1. So what was the general result on the slide? N factorial plus 1 cannot be divided by any number from 2 to. अगर यहां 2 कर देते तो प्रॉब्लम हो जाती, क्योंकि 2 से ये भी डिवाइड हो जाता, 2 से ये भी डिवाइड हो जाता. अब ऐसे क्वेश्चन भी अटेम्प्ट कर सकते हैं. 3 होता तो ये 3 से डिवाइड हो जाता. अब एक काम करेंगे आप, दैट इज आई नॉर्मली टेल इन माय क्लासेस टू ऑल माय स्टूडेंट्स कि आप जो क्वेश्चन कर रहे हैं उसके आसपास के क्वेश्चंस खुद फ्रेम करें और सोचने की कोशिश करें कि इसमें हम कैसे फ्रेम. जैसे अभी हमने 2 क्वेश्चन और फ्रेम कर लिए. +5 होगा तो क्या होगा, +7 होगा तो क्या होगा, और ऐसे क्वेश्चंस पास ऑन टू योर फ्रेंड्स एंड सी वेदर यू कैन सॉल्व इट. क्वेश्चन फ्रेमिंग इज द की टू question solving sometimes, because when you are framing questions you will think of about all the possibilities. तो अगर किसी कंसेप्ट के आसपास की सारी चीजें आप सोच लेंगे तो एग्जामिनर उससे बाहर कुछ नहीं दे पाएगा. So always form this practice. Let us go to the next. Oh, this is a bit tricky. It says they have given 2 raised to power n. Let's read the question first. It says the largest integer n such that 33 factorial is divisible by n 2 raised to power n. इनमें से कौन सी चॉइस होगी? n 16 होगा, 32 होगा, 15 होगा, 31 होगा. क्वेश्चन क्लियर है? The question is, I want to try powers of 2. That means 2, 2 square, 2 cube, 24 एंड सो ऑन. 2 raised to power 10 is 1024. सपोज हम देखना चाहते हैं कि क्या अगर इसको 2 raised to power 5 भी डिवाइड करता है और 2 raised to power 8 भी डिवाइड करता है और 2 raised to power 9 डिवाइड नहीं करता, तो इसका मतलब हमारा आंसर क्या हो गया? 2 raised to power 8. तो हम देखना चाहते हैं कि 2 की सबसे बड़ी पावर कौन सी है जो 33 फैक्टोरियल को डिवाइड करती है. इसको हम ऐसे अटेम्प्ट नहीं करेंगे. लेट अस सी द रिजल्ट. प्लीज शो द नेक्स्ट स्लाइड. दिस इज द रिजल्ट. लेट्स स्पेंड सम टाइम ऑन दिस because it is involving a number of notations. Because this question has been asked sometimes in engineering examinations as well as MC entrance examinations. So and it is also I think a similar problem is given in your Udaan notes also. You see them. Have you read them? Please read them also whenever you get time. This is a notation EP of n factorial. That means we are trying to find out the highest power of P that divides n factorial. Let us take EPN as that. EP of n factorial means what is the highest power of P that will divide n factorial. This we are trying to calculate. It says it will be done like this. First of all, you take n. Suppose I take n as 33 and P is 2 in our case. We want to see कि 2 की कौन सी सबसे बड़ी पावर 33 फैक्टोरियल को डिवाइड करती है. तो दो नंबर हमारे सामने हैं. 2 जो कि एक प्राइम नंबर है और 33 जो एक नंबर गिवन है जिसके फैक्टोरियल को हमने देखना है 2 की कौन सी पावर डिवाइड करती है. तो वी चूज n as 33 एंड p as 2. अब हम पहले सिलेक्ट करते हैं कि 33 को 2 की कौन कौन सी पावर डिवाइड करती है. दिस इज सिंपल टू चेक. 2 की फर्स्ट पावर इट डिवाइड्स 33. सेकेंड पावर 2 is 4. This symbol is for divides. I'm not writing 2 by 33 or 2 square by 33. This symbol means whether 2 divides or not. 2 square divides 33 or not. 2 cube is 8. Does it divide 33? What about 2 raised to power 4? I'm sorry. Let me put it more clearly. हम देखना चाहते हैं इसके लिए 2 की कितनी पावर्स 33 से छोटी है, नॉट डिवाइड. 2 तो 30 को डिवाइड नहीं कर रहा. आई एम सॉरी फॉर दैट. 2 की फर्स्ट पावर 33 से छोटी है. 2 की पावर 2 33 से छोटी है. 2 की पावर 3 33 से. 2 raised to power 4 33 से छोटा है. 2 raised to power 5 33 से छोटा है. और 2 raised to power 6 33 से छोटा नहीं है. राइट. प्लीज शो द स्लाइड. सी द क्वेश्चन. नीचे एक कंडीशन लिखी है. दिस कंडीशन आपको वो s निकालना है कि p की पावर s तो n से छोटा हो या इक्वल हो, लेकिन p रेज्ड पावर s प्लस 1 छोटा नहीं हो. तो यहां में मिल गया. बिकॉज यू कैन सी हियर 2 raised to power 5 is less than 33 but 2 raised to power 6 is not less than 33. तो हमारा s क्या आ गया? s is equal to 5. So first step is from the given question we have to find s. हमारा क्वेश्चन क्या था? 33 फैक्टोरियल को 2 की मैक्सिमम कितनी पावर डिवाइड करेगी 33 फैक्टोरियल को. तो हम स्टार्ट कहां से करते हैं? वी बिगिन विद 33. चूज p. p will always be a prime number. Such questions can be handled normally only with prime numbers. Then we'll take some other problems also where these are not prime. तो इस केस में s is equal to 5 आ गया. s क्या है? 2 raised to power 5 33 को डिवाइड करता है. 2 raised to power 6 नहीं करता. तो s की वैल्यू 5 आ गई. अब देखिए इसमें s का रोल है. अब ये जो नंबर निकाला गया है ईपी एन फैक्टोरियल, ये इसमें कुछ सिंबल्स लिखे हैं, एन को पी से डिवाइड करो और ये स्क्वायर ब्रैकेट, यू अंडरस्टैंड, ग्रेटेस्ट इंटीजर फंक्शन, एन को पी से डिवाइड करो और देखिए कौन सा सबसे बड़ा इंटीजर मिलता है इससे, फिर एन को पी स्क्वायर से डिवाइड करो, देखो कौन सा सबसे बड़ा इंटीजर मिलता है ग्रेटेस्ट इंटीजर फंक्शन से, एन पी क्यूब और एन पी एस। इस केस में हमें क्या क्या करना होगा, एन इज 33 by 2 greatest integer function, then 33 by 4 greatest integer function, 33 by 8 greatest integer function, 33 by 16 greatest integer function, and 33 by 32 greatest integer function. We have to stop here because we can't go beyond this. जो एस सबसे बड़ा मिला था उसके लिए निकालना था। इसका रिजल्ट क्या आएगा, 16, 33 divided by 2 is 16.5, but we want only the integral part. So this is the integral part, 8, 4, 2, 1. अगर आप इसके आगे कंटिन्यू भी करते, अगर मान लीजिए 33/2⁶ लिखते तो वो 0 हो जाता। तो 33 को जब आप 64 से डिवाइड करेंगे तो इंटीजर तो 0 ही आएगा, 0 पॉइंट समथिंग आएगा। तो आगे कंटिन्यू करते तब भी फॉर्मूला ठीक था, इसीलिए इसको यहाँ पर रोक दिया गया है, इट हैज स्टॉप्ड हियर बिकॉज अदर वैल्यूज विल ऑलवेज बी 0. व्हाट इज दिस, 24, 28, 31. कैन वी सी द लास्ट स्लाइड, लास्ट नहीं, द प्रीवियस स्लाइड, आई एम सॉरी. Yes, this question. Please, the previous slide. That contains the question. तो 2 की पावर कितनी 33 फैक्टोरियल को डिवाइड करेगी? One of the choices 31. That is the answer. Now you can tackle all such problems. Had you tried this problem earlier? So you have to find out new problems. Try all the problems given in your Udaan notes or any book you can lay hands on. जो भी किताब हाथ में लगे उसके प्रॉब्लम्स ट्राई करने की कोशिश करो. मैंने कुछ कंसेप्ट अभी दे दिए हैं, अब इनके बेस पर हो सकता है कोई कंसेप्ट रह गया हो, बिकॉज द नेक्स्ट क्लास इज ऑल्सो ऑन बाइनोमियल थ्योरम. देयर आर सम गुड प्रॉब्लम्स ऑन कॉम्बिनेशंस यू कैन सॉल्व ओनली आफ्टर यू नो बाइनोमियल थ्योरम. So even if something is left out, we can cover up in the next class. So are you following everything? That is more important, that whatever little we do, that you should understand. Now let us see some miscellaneous problem, and there will be some problems where we'll have to think. And so if a new concept comes up, we'll try it there and then only. The question is, which is greater, 15C25 or 15C26? 50C26. The first question, there are 4 questions here. Let us see one by one. First question is, which one of the 2 numbers written here, the numbers are the questions can be as simple as this one. 50 C25, 50 C26, which is greater? By the way, all of you should clearly understand that 50 C25 or 50 C26, they are all natural numbers. NCR is always a natural number. Okay, it cannot be a fraction. So इनमें से कौन सा बड़ा है? The reason is we have this general result. NCR की मैक्सिमम वैल्यू क्या होती है? Let us try to see. देखें, सपोज हम एक छोटा सा एग्जांपल लेते हैं, हम सिर्फ 4C2 कंसीडर 4CR कंसीडर करते हैं. 4C क्या क्या हो सकता है? 4C0, 4C1, 4C2, 4C3 एंड 4C4. 4C1 कितना होता है? 1 and C0 is always in. What is 4C1? 4. What is 4C2? 6. What is 4C3? 4. C4 is 4 and 1. So you can see it increases and then it decreases. So what is this has to do with this? N by 2. N by 2 is always maximum. If n is even. अगर n even है तो मैक्सिमम वैल्यू NC n by 2 की होगी. तो 25 C25 की वैल्यू मैक्सिमम होगी. अब हमें ये बिल्कुल परेशान नहीं करेगा ये 26 है या 28 है या 48 है या 10 है. अगर कोई और नंबर होता तो हमें कंपेयर करना पड़ जाता. तो इस क्वेश्चन में तो कुछ हमें सोचना नहीं है. कैलकुलेशंस करके भी आप निकाल सकते हैं दोनों की, पर कैलकुलेशन मींस यू आर wasting your time in the examination. So if n is an even number, NCR is maximum when R is n by 2. What if it is odd? हम एक odd का केस भी देख लें. Let us see all the combinations with the help of 5. 5CR, 5C0, 5C1, 5C2, 5C3, 5C4 and 5C5. This is 1, this is 5 and also this is going to be 1 and 5. You can always write like this. What is 5C2? 10. 5 into 4 divided by 2 factorial. It is 10. This is also 10. So the maximum value occurs at two places. And what are those values? If you have NCR and n is odd, then what has happened? NC n minus 1 by 2 and NC n plus 1 by 2. These are the two values which will be the largest. तो 5 के केस में 5C 5 minus 1 क्या होगा? 4 divided by 2, that means 5C2 and 5C3. अगर n odd है तो NCR की मैक्सिमम वैल्यू कहां पर होगी? जब R की वैल्यू n minus 1 by 2 होगा और n plus 1 by 2. तो 5 के लिए 5 minus 1 by 2 2 बनता है और 5 plus 1 by 2 3 बनता है. तो हमारे पास 5C2 और 5C3 ग्रेटेस्ट होंगे. अब ये सारे क्वेश्चंस मुझे लगता है आप आंसर कर सकते हैं. 49 C24 और 49 C28, क्योंकि 49 यहाँ एक ऑड नंबर है, इंटेंशनली मैंने ऑड लिया है. अगर ये ऑड है तो इसकी मैक्सिमम वैल्यू पहले 49 में से 1 सब्ट्रैक्ट करो, 48 आएगा, उसको 2 से डिवाइड करो 24, और दूसरा 49 प्लस 1 करो 50 आएगा, 2 से डिवाइड करो 25. तो 49 C25 और 49 C24 की जो भी वैल्यू होगी वो लार्जेस्ट होगी. कितनी होगी हमें कैलकुलेट करने की जरूरत नहीं है, क्योंकि दूसरा नंबर 49 C25 नहीं है. अगर वो 25 होता तो ये इक्वल होते दोनों. And if it is something different from 24 in place of R, it has to be less. 28 वाली ये वैल्यू जो है इससे छोटी होगी. Is that clear? Which is true? I have written two things, this and this. 50C25 and 50C24 ये इक्वल नहीं है. ये रिजल्ट इवन नंबर्स के लिए ट्रू नहीं है कि दो मैक्सिमम मिलेंगे. तो अगर वैसे इसमें कौन सा बड़ा है? 50C25, क्योंकि लार्जेस्ट है तो वो बड़ा है. और इसमें क्योंकि 49 में से जब हम एक सब्ट्रैक्ट करके 2 से डिवाइड करते हैं 24 आता है, तो 49C24 मैक्सिमम होगा जितने भी 49CR हम निकालते हैं. तो राइट हैंड साइड पे 49C40 है, वो डेफिनेटली इससे छोटा होगा. और फोर्थ क्वेश्चन, क्योंकि हमने 2n लिख दिया है ना, The clue is it is 2n. It's even. तो 2n का half क्या होगा? n. तो 2n Cn is maximum. So if there is anything else, क्योंकि अगर यहाँ पर even है तो इसके दो maximum नहीं है, एक maximum है. तो ये definitely, so this result is false. We can always see that. This is really true. Answer is yes. Let's go to the next slide. Oh, when is NPR equal to NCR? Very simple. I mean, these are mixed problems. Sure. They are equal for these two values. And what happens for R is equal to N? What is NPN? It is N factorial. NCN is 1. So they cannot be equal. Unless N itself is 1. Unless N itself is 1. This you will try yourself. Okay. There is a standard result also here. NCR minus 1 and NCR, their sum is always equal to N plus 1 CR. You can use this result. NCR plus NCR minus 1 is equal to N plus 1 CR. You can prove this also. It's pretty simple. Find out the value of this, write the value of this, take LCM, you will get that. So sometimes if you know the result, it will be easier that it is 11C1 because here both the the numbers we have written 10C6 and 10C7 start with 10, and in the denominator we have 6 and 7. So 7 is R. So it must be 11C. Otherwise, what will happen? You will try to solve. That will take some time. Let's go to the next problem. This is a, okay. This is the result I was using there. But still I am asking you, NCR plus NCR minus 1 is equal to NCR. We said this is true. For what value? This is not true. किसी इनमें से किसी एक वैल्यू के लिए इनवैलिड होगा ये? R equal to 0 के लिए किस लिए वैलिड नहीं है? This is not valid. Otherwise, whenever the expressions are valid, the result is true. NCR plus NCR minus 1 इसका मतलब R की वैल्यू 1 से लेकर n तक कुछ भी होगी उसके लिए ट्रू होगा. सिर्फ एक केस था. Just I wanted to bring this to your notice. That's why I have written this problem. So now, next question is simple. Which of the following is true? Okay. I used a different notation by chance here, but that's for good. Because in the examination, alternative notations can be used. NPR that we have been writing, some books will write it as PNR, and some books also write it as within brackets they write N at the top and R here, this one. इनमें से कौन सा correct है? She is saying that A is correct. Let us see. अगर हम P16 5 लिखें तो ये क्या होगा? 16 factorial divided by 5 factorial. No, divided by 11 factorial. So it is 16 into 15 into 14 into 13 into 12. What is P16 8? 16 factorial divided by 16 minus 8, that means 8 factorial. So you will have 16, 15, 14, 13, 12, 11, 10, 9. So which is bigger? This is bigger. So for the smaller integer, which is the smaller out of 5 and 8? 5 is the smaller, then 16 P5 has to divide 16 P8. This was simple. Okay, let's see the next set of questions. In how many ways a number between 3000 and 4000 can be formed using 3, 4, 5, 6, 7, 8? I think we have already seen a problem of this type. We can leave it. You try yourself. How many of them are divisible of 5? I mean, this type of questions are important. Suppose I quickly see one part of the above, the question that is written at the top. 3, 4, 5, 6, 7, 8 इनको मिलाकर 3000 और 4000 के बीच में कितने नंबर बनाए जा सकते हैं? तो if the number is to lie between 3000 and 4000, it should start with 3. इसका मतलब इसके लिए हमारे पास एक ही चॉइस है, 3, 4, 5, 6, 7, 8. इनकी हेल्प से हमें नंबर बनाने हैं. कितने डिजिट के नंबर्स बनाने हैं? 4 डिजिट के, क्योंकि हमें 3000 और 4000 के बीच में चाहिए. Because the first number must start with 3, there is only one choice. Suppose I am taking the repetition is permitted. So how many choices are for this place? 3 included, because you can have 3300 and something. So 6 choices, 6 choices, 6 choices, because this was permitted. So there were 216 choices. Similarly, we can deal with the case when there are is there an answer? Oh, I have taken that digit is repeated. Options may be incorrect. You can always solve it. But now my question is, I am interested in how many of them will be divisible of 5. A number is divisible of 5 if the units place, at the units place we have either 0 or 5. अब हमारे पास जो डिजिट्स गिवन है, जिनकी हेल्प से हमें 3, 4, 5, 6, 7, 8 हैं, जिनकी हेल्प से हमें 4 डिजिट नंबर बनाने हैं, उसमें कितने हैं 0 और 5 में से? सिर्फ 5 है. तो इसके लिए हमारे पास एक ही चॉइस रह गई. अब हमारा फर्स्ट डिजिट यहाँ पर एंड लेफ्ट से राइट पर जो 1000 का डिजिट है वो फिक्स हो गया, वहां पर 3 आना है, और लास्ट डिजिट फिक्स हो गया, वहां 5 आना है. तो बीच के लिए चॉइसेस देखनी है. अगर आप रिपीटिशन परमिट कर रहे हैं तो 6 into 6 चॉइसेस हो जाएंगी, क्योंकि आप 5 को दोबारा भी लिख सकते हैं, 3 को दोबारा भी लिख सकते हैं. अगर आपको रिपीटिशन परमिट नहीं करनी तो 3 और 5 को छोड़कर जितने नंबर हैं उतनी चॉइसेस आप इसमें कर सकते हैं. सो दिस वाज you can always tackle questions of this type. We have already done some problems of this type. Let us go to the next problem. Now this you can try. We just tackled the exponent of 2 in 33 factorial. That is what I was mentioning, that 2 is a prime number, but here 15 is not a prime number. So 50, but you know that every natural number can be expressed as product of 2 primes. Okay, I mean number greater than 2. 2 को आप 2 प्राइम्स में नहीं तोड़ सकते हैं, 1 को नहीं तोड़ सकते हैं, but it's true for all other numbers. हमने ये देखना है कि 15 का मैक्सिमम एक्सपोनेंट कितना आएगा. तो हमें देखना पड़ेगा, बिकॉज 15 is 3 into 5. 3 की मैक्सिमम पावर कौन सी है जो 100 फैक्टोरियल में आती है, और 5 की मैक्सिमम पावर कौन सी है जो 100 फैक्टोरियल में आती है. And the technique is, let us do this question. I think what was the technique? You remember, because the numbers involved are 100 and 15. First of all, we choose PS3, and the first thing we see is 3 की maximum power कौन सी है जो 100 को divide करती है. Sorry, 100 से छोटी है. 3 is less than 100. 3 square is less than 100, so on. 3 raised to 4 कितना होता है? It is 81. That is also less than 100, but 3 raised to 5 is not less than 100. तो हमने जो S चूज करना था वो S4 हो गया, क्योंकि 3 की पावर 4 है जो मैक्सिमम पावर 3 की इसको डिवाइड करेगी. द मैक्सिमम नंबर विद पावर ऑफ 3 इज दिस. तो आप देखेंगे कि 100 फैक्टोरियल में अब क्या होगा. उसके लिए हमें क्या करना है, 100 को 3 से डिवाइड करके ग्रेटेस्ट इंटीजर फंक्शन निकालना है, 9 से डिवाइड करके ग्रेटेस्ट इंटीजर फंक्शन निकालना है. देन वी हैव टू फाइंड 100 अपॉन 27. This is third power, and what is the fourth power? 81. That was the formula I wrote for E300 factorial. 100 फैक्टोरियल में 3 की कितनी पावर आएगी मैक्सिमम, उसको निकालने के लिए हमें ये सब करना पड़ता है. We have done a case already. 100 upon 3 is 33, 100 upon 9 is 11, 100 upon 27 is 3, 100 upon 81 is, so it is 33 plus 11, 44 and 48. Similarly, we can do for, I am also interested in finding out E500 factorial. तो मुझे पहले ये देखना पड़ेगा कि 100 के लिए और 5 के लिए S क्या है, यानी 5 की मैक्सिमम पावर कौन सी है जो डिवाइड करती है 500 से कम है, 5 का स्क्वायर 100 से कम है, 5 का क्यूब 100 से कम नहीं है, वो एक्सीड कर जाता है, तो यहाँ पर S हमारा 2 आ गया, मतलब 5 की मैक्सिमम 2 पावर है जो 100 से छोटी रहती है। तो अब हमें क्या करना पड़ेगा, 100 डिवाइडेड बाय 5 प्लस 100 डिवाइडेड बाय 5 स्क्वायर, इनके ग्रेटेस्ट इंटीजर फंक्शंस कैलकुलेट करने पड़ेंगे। इसका इंटीग्रल पार्ट 20 है, इसका इंटीग्रल पार्ट 4 है। अब देखिए 3 की मैक्सिमम पावर 48, 3 रेज़ पर 48 100 फैक्टोरियल को डिवाइड करता है और 5 की पावर 24 डिवाइड करती है। हमारा इंटरेस्ट है 15 को देखने में, तो 15 कब अकर करेगा, जब 3 भी अकर करेगा और 5 भी अकर करेगा। तो कितने 3 और 5 के पेयर मिलेंगे, इसका और इसका मिनिमम। अगर 3 कम हो 5 ज्यादा हो, अगर ये 24 होता और ये 48 तो भी हमें 24 ही मिलने थे 15, अब भी हमें 24 मिल रहे हैं। तो इसीलिए उस क्वेश्चन को एक बार दोबारा देखते हैं। उस क्वेश्चन में क्या इन्वॉल्व था कि 15 का कितना एक्सपोनेंट, कितनी पावर 100 फैक्टोरियल को डिवाइड करती है, इसमें चॉइस 24 आएगी। कोई मुझे नेक्स्ट क्वेश्चन का सॉल्यूशन बता सकता है? 100 फैक्टोरियल के एंड में कितने जीरोज आएंगे, कैलकुलेट कर लिया? ओके, किसी भी नंबर के एंड में जीरोज इंडिकेट करते हैं उसमें कितने टेंस इन्वॉल्व है। ओके, 2500 इज 25 इंटू 10 इंटू 10। तो हमें देखना है कि कितने जीरोज हैं, यानी 2 की पावर मैक्सिमम कितनी इन्वॉल्व है वो देख लेंगे इस फॉर्मूले से, और इसी तरह से 5 के निकाल लेंगे और देख लेंगे उनका मिनिमम क्या है, उससे निकला है। ये आप देख लीजिएगा जो भी आंसर है। ओके, लेट्स प्रोसीड टू द नेक्स्ट क्वेश्चन। Oh, this was something that was left. Circular permutations. They are important. If you have 5 persons and they have to sit in a row, A1, A2, A3, A4, A5, all their total permutations are 5 factorial. That's, you know. But what if they are sitting on a round table? The result is 4 square, 4 factorial, because in a round table, somebody sits here. So 1, 2, 3, 4 choices are there. अब जो पहला, the first person who takes a seat wherever it takes is unimportant, क्योंकि यहां दोनों एंड्स मिले हुए। अगर हम इसको रो में बिठाते हैं, इनको 1, 2, 3, 4, 5, और इसकी बजाय सर्कल में बिठा रहे हैं 1, 2, 3, 4, 5, इसमें आप डिफरेंशिएट कैसे करते हैं कि 1 के लेफ्ट पे 2 है और 2 के लेफ्ट पे 3 है, 4 के लेफ्ट पे 5 है और 3 इसके राइट पे है। इसमें कैसे करेंगे, 1 के लेफ्ट पे नहीं, यहां से देखें, चलिए यू वांट टू टेक दिस वे। 1 के लेफ्ट की बात कर रहे हैं तो 5 होगा, 1 के लेफ्ट पे बात कर रहे हैं, वो वहां बैठा है ना, और 1 के राइट पर 2 है। अब 1 अगर यहां बैठ जाता और फिर से हम ये लिख देते 2, 3, 4, 5, तो कोई फर्क पड़ता? 1 के लेफ्ट पर 5 वही रहता। तो फर्स्ट पर्सन ने, जो पहला आदमी बैठा, उसने क्या पोजीशन ली, उससे हमें फर्क नहीं पड़ता। इसीलिए हम इसमें से फर्स्ट, अगर इफ देयर आर n पर्सन्स we let the first person sit, the remaining are n minus 1, we take n minus 1 factorial. Yes, but one thing matters. आप clockwise और एंटी क्लॉकवाइज परमुटेशंस में अरेंजमेंट में फर्क कर रहे हैं कि नहीं. फॉर एग्जांपल हमने यहां से बैठाना शुरू किया और 1 2 3 4 5 यहां बैठे, या यहां से किया और 1 2 3 4 5 ऐसे बैठ गए. अब इनमें डिफरेंस है क्योंकि यहां पर 1 के राइट पर 2 है, वहां पर 1 के लेफ्ट पे 2. सो दे आर different arrangements. If you want to tell somebody that the person in the white coat is the chairman and the person sitting on the left is his secretary, तो left और right में फर्क पड़ेगा. That matters. And where arrangement matters, you have to be careful. तो अगर आप clockwise और anti clockwise permutation में differentiate नहीं करते हैं तो नंबर n-1 फैक्टोरियल है, और डिफरेंशिएट करते हैं तो n-1 फैक्टोरियल डिवाइडेड बाय 2 हो जाएगा, डिपेंडिंग ऑन आप ये वाला लेना चाहते हैं ये वाला या दूसरे वाला कॉम्बिनेशन परमुटेशन लेना चाहते हैं, क्लॉकवाइज और एंटी क्लॉकवाइज. इज दैट ओके? सो दिस इज समथिंग यू हैव टू बी केयरफुल. और जब एंटी क्लॉकवाइज और क्लॉकवाइज मैटर नहीं करते, मतलब आप इधर से भी काउंट करें या उधर से फर्क नहीं पड़े, वो कब होगा? इन द नेक्स्ट एग्जांपल देयर आर 6 बीट्स ऑफ द सेम साइज, सेम कलर, सेम शेप, दैट मींस दे आर एग्जैक्टली सिमिलर, और उनकी हेल्प से हमें एक नेकलेस बनाना है. तो उसमें ये फर्क नहीं पड़ेगा कौन सा किसके लेफ्ट पे कौन सा किसके राइट पर है. तो इस केस में 6 है ना, और उसको सर्कल, सर्कल का मतलब सर्कल नहीं, एनी क्लोज कर आप इलिप्टिकल बना दीजिए. इसका मतलब यह है कि आपकी जो माला है, नेकलेस है, उसको चाहे तो आप सर्कुलर में अरेंज कर लीजिए, चाहे उसको थोड़ा खींचकर वी कैन अरेंज इट एज एन एलिप्स, और इवन आई कैन पुट इट लाइक दिस. द ओनली थिंग इज इट शुड बी ए क्लोज कर्व. सो व्हाट विल बी द आंसर नाउ? 5 फैक्टोरियल डिवाइडेड बाय 2 because there are 6 beats in a circular arrangement, so 5 factorial is the number, but we cannot differentiate between the clockwise and the anti-clockwise arrangements, so therefore we divide by 2. This has to be taken care of in case of circular permutation, circular arrangements. Next question in this, no, please show the same slide. In how many ways can 6 persons be seated on a round table if there are only 6 seats? Okay, that's okay. Suppose I take persons are 10. What I wanted was if there are 10 persons and there are only 6 seats. So first we have to select which 6 persons will be seated, and then we have to take the arrangements of those 6 people. अगर 6 ही लोग हैं और 6 ही सीट्स हैं फिर तो 5 फैक्टोरियल आंसर हो ही गया. So the corrected question is, in how many ways can 10 persons or some other number be seated on a round table if there are only 6 seats? The result is this, NPR upon, okay, that is the result. You can use this cell and solve it. Similarly, that is if clockwise and anti-clockwise orders are taken as different orders. But if they are not, then this number will, because you will divide it by 2 then. So this way you can try some problems on this. But this is important. Let me see the next question on the next slide. What is that? Okay, then let me concentrate only on circular permutations. They are important. Let's take some questions otherwise. Suppose there is a round table and there are 3 boys and say 4 girls. Let me take a smaller number, 2 girls. And there are 5 chairs here. They have to sit. How many possible arrangements are there? Because there are total 5 numbers and 5 seats are there. Total is 4 factorial. But suppose both the girls want to sit together. If the condition is both of them want to sit together, that means we can have a girl here a girl here, a boy here, boy here, a boy here. I've named boys as B1, B2, B3 and girls as G1, G2. So now what you do? So normally what we do is we club them. Both the girls are taken as one because whenever they will sit at the adjoining seats. So first of all, we take them as one. Now what is the total number of persons? 3 boys and 1 pair of girls. So there are 4. In how many ways can we arrange 4 people? It's 3 factorial. So 3 factorial possible arrangements are there. But you can see that this arrangement, which I have shown here, G1, G2 or G2, G1, they are different. If G1 is here and G2 is here, then G2 is on the left of B3. Here, if G1 is here, the girl on the left of B3 is G1. So these two are different cases. So what we have to see is, out of 2, how many arrangements can be made? Taken both together is 2 factorial. That means there are 2. So we multiplied by this. So there are total how many cases? 12 possible arrangements. And now we can extend it to any number. Suppose there are 7 boys and 5 girls and all the 5 girls want to sit together. That means 7 plus, we will take 5 girls as one number. 7 plus 1 is 8. So 8, there are total 8 persons. In how many ways can we arrange them? 7 factorial multiplied by 5 factorial, because 5 girls within themselves can be arranged in 5 factorial ways. Okay. Now take one more question. 1, 2, 3, 4, 5. How many, suppose these are 5 seats, how many seats can be arranged within them? 1, 2, 3, 4, 5. So I take a case of 5 men and 5 women. And we want to make an arrangement that a man and a woman sit alternate. That means between every 2 men, there is a woman, and between every 2 women, there is a man. इसको कैसे tackle करेंगे? Let us see. What we do is, first we say take 5 gentlemen and ask them to sit, leaving one side, one of the chairs. So how many chairs they can occupy? 5. So 5 people can occupy 5 seats on a round table in 4 factorial ways. Now it is simple. The remaining women, they will sit on the remaining. So there are 4 factorial ways. Okay. And do we have to care about what happens where? Suppose this particular man is M1, this is M2. Do we need to take care of this कि यहाँ पर W1 बैठा है या W2 या W6? That will already be taken care. क्योंकि आपने इन सब प्लेसेस में सारे केसेस कंसीडर कर लिए हैं. जब W1, W2, W3, W4 और W5 हैं, 5 विमेन, इनको बिठा रहे हैं तो सारे केसेस आ गए ना, कौन किस चेयर पर बैठेगा, तो अलग से कुछ देखने की I don't think there is any need. So this is the calculation for this. So similarly, as I told you, you always think of more problems. अगर आपको मान लीजिए किसी, there are suppose 6 boys are there, उसमें से किसी ने ये कहा कि मुझे इसके साथ नहीं बैठना, then what? That means there must be at least one person between that boy. Suppose 1, 2, 3, 4, 5 places are there, and there are 5 boys, B1, B2, B3, B4 and B5. B1 does not want to sit with suppose B4 and B5. उनके लेफ्ट राइट पे B4, B5 बिल्कुल नहीं होने चाहिए. तो हमें क्या करना पड़ेगा? हाँ, it's better we first make the person seated. या organization भी आपको करना पड़ेगा. Suppose B1 sits first. Now here and here we cannot have B4, we cannot have B5. तो यहाँ पर के लिए कौन कौन है? B2, B3. अब कितने पॉसिबिलिटीज हैं? हाँ, B1 here, B2 here, B3 here और B3 here. तो there are two choices. Suppose एक चॉइस ये हो गई. अब कितनी सीट्स बची हैं? 2 सीट्स. उन पे B4, B5 में बैठना है. उसकी भी 2 चॉइसेस. तो टोटल नंबर ऑफ चॉइसेस आर. उसकी पोजीशन को हम उसके लिए 5 पोजीशन हम नहीं गिन रहे हैं पहले, क्योंकि फर्स्ट पर्सन व्हेन द पर्सन सिट्स ऑन द चेयर ऑन ए राउंड टेबल, दैट इज मीनिंगलेस. अब उनकी, क्योंकि आप पूरा मान लीजिए, सपोज यू आर सिटिंग ऑन ए प्लेटफॉर्म on which the round table is kept, you can always rotate the platform. अगर बिल्कुल यहाँ पर आना चाहता है फ्रंट में, तो हर लोकेशन फ्रंट है, वो जहां पर बैठ जाएगा हम पूरा घुमा के उसको वहां कर देंगे. क्योंकि हम राउंड टेबल में डिफरेंशिएट कैसे करते हैं पोजीशन को, कि लेफ्ट पे कौन है, राइट पे कौन है, और डिफरेंशिएशन नहीं हो सकता. So is that okay? Any questions if till now if you want? Are there any online questions? Okay, then we can see the remaining slides also. We do have some time still. This was a question of number of ways in which 5 boys and 3 girls can be arranged in a row. That's simple. That's simple. Let's proceed. Please, let us see this question on quadrilaterals. Some geometric problems we have not seen. As I told you that if some particular type of problems are left out, since the next session is also on binomial theorem, and some problems of combinations we'll be doing while we know binomial theorem. So we'll continue with this topic and then come to binomial theorem in the next class. But let us see. This is yes a good question. How many quadrilaterals can be drawn? First of all, let us start like this. Given one line, how many? Given one point, how many lines can be drawn through it? If the infinite lines. Suppose I take 2 points lying on the same plane. How many straight lines? 1. If I take 3, how many straight lines? Oh, how many lines can be drawn? No, not 3. If there are 3 points, and how many lines can you draw? Which? Okay, this line, and this line. So result is 3C2. Whichever 2 points you choose. So result is clear. If there are n points and all of them are non-collinear, I mean no 3 of them are collinear. आप कभी भी 2 पॉइंट ऐसे नहीं बना सकते जो कोलिनियर ना हो, एक लाइन में ना लाई करें. 2 पॉइंट तो हमेशा एक लाइन में लाई करते हैं. अगर आपको 4 पॉइंट ऐसे गिवन है जिनमें से कोई भी 3 कोलिनियर नहीं है, तो इसका मतलब 1 लाइन, 2 लाइन, 3 लाइन, 4 लाइन, 5 और 6 ये आप ड्रॉ कर सकते हैं. व्हाट इज द रिजल्ट? 4C2. तो अगर आपके पास 4 पॉइंट्स हैं जो एक लाइन, उनमें से कोई भी 3 ले लो, वो एक लाइन में नहीं है. हम चाहते हैं कि हम उनको उनमें से 2-2 के पेयर मिलाकर कितनी लाइन ड्रॉ कर सकते हैं, क्योंकि 2 लाइन से एक 2 पॉइंट से एक लाइन बनती है. तो सवाल ये हो गया कि 4 पॉइंट्स हैं जो जिनमें से कोई 3 कोलिनियर नहीं है, तो 4 में से 2 हम कितने तरीके से सिलेक्ट कर सकते हैं? 4C2. दैट इज ओके. तो जनरल क्या हो गया? अगर n पॉइंट्स हैं, उनमें से कोई भी 3 कोलिनियर नहीं है, तो NC2 इज द नंबर ऑफ लाइंस वी कैन ड्रॉ पासिंग थ्रू n पॉइंट्स, not passing through n point, given n points, joining 2 points, any 2 points from out of those we have to draw lines. तो total points कितने lines बन जाएंगी? NC2. हम triangles की बात कर सकते हैं. 3 पॉइंट अगर कोलिनियर नहीं है, मैं तेज नहीं जाता. This is okay, I suppose. Suppose अब हमारे पास 3 पॉइंट है और वो एक ही लाइन में लाई नहीं करते, तो उनसे एक ट्रायंगल बन जाएगा. और अगर तीनों पॉइंट एक ही लाइन में हो गए तो वो नहीं बन सकता ट्रायंगल। अब हम ट्रायंगल्स काउंट करने की कोशिश कर रहे हैं। सपोज हमारे पास 4 पॉइंट्स हो और चारों में से कोई भी 3 कोलिनियर नहीं हो, तो हम कितने ट्रायंगल्स बना सकेंगे? 4C3, because out of 4 we have to select 3 at a time. Now I need not draw. आप इन तीनों से बना लीजिए, इन तीनों से बना लीजिए, दिस और दिस। क्वाड्रिलेटरल्स कितने बनेंगे? 1। अगर 5 पॉइंट ले लें, सब सपोज नॉन कोलिनियर है सबके, जब भी मैं पॉइंट्स के नॉन कोलिनियर होने की बात कर रहा हूं तो मतलब कोई 3 नॉन कोलिनियर है, तो 5C4 5 हो जाएंगे, लेकिन इसमें से 2 तो डायगोनल हो जाएंगे। 5C रुके 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 रुके, अगर 4 पॉइंट्स हैं, इनसे कितनी स्ट्रेट लाइंस बनती हैं? 4C2 6, और क्वाड्रिलेटरल 1। ये ठीक है। उस क्वाड्रिल के डायगोनल्स कितने हैं? 2। तो अगर कहीं आपको डायगोनल सेपरेट करने पड़ेंगे तो यहां से मिलेंगे ना। एक क्वाड्रिलेटर बन रहा है तो कितने डायगोनल्स बन रहे हैं? 2। चलिए, अब हमारा क्वेश्चन कुछ टेढ़ा था, उसमें था कि दैट इज क्लियर।
सर 5 वो वहां पे हमारे पास 5 पॉइंट्स थे, हमें क्वाड्रिलेटर बनाना था। इट विल बी 5C4 दो डायगोनल्स होते हैं तो 5C4 -2 नहीं हो सकता।
5C4 जब आप ले रहे हैं तो इसमें आपने क्या किया? 2 डायगोनल्स भी काउंट कर लिए हैं, तो आपको डायगोनल्स वो सब्ट्रैक्ट करने पड़ेंगे टोटल। देख लो जरा, जस्ट सी। ओके,
डायगोनल्स को माइनस क्यों करना है? हमें तो क्वाड्रिलेटर बनाना है। क्वाड्रिलेटर डायगोनल्स पे बन जाएंगे। डायगोनल्स को क्वाड्रिलेटर कैसे बनाएंगे? ट्रायंगल बनता है।
let us see.
नहीं 4 पॉइंट्स ले।
Okay, let's do one thing, because I want to give you some food for thought also. Let us leave this problem here and you think over. Okay, so in the next class we'll start from here and I will give you all that. I want you to think कि अगर आपके पास कुछ पॉइंट्स गिवन है, सपोज 5 पॉइंट, 6 पॉइंट, 7 पॉइंट, और कंडीशन क्या मैं दे रहा हूं कि उनमें से कोई भी 3 कोलिनियर नहीं है, क्योंकि 2 तो हमेशा कोलिनियर होंगे। अगर 5 पॉइंट है तो कितने डायगोनल्स, कितने क्वाड्रिलेटर बनेंगे? 6 पॉइंट है तो कितने क्वाड्रिलेटर बनेंगे? और उससे ज्यादा पॉइंट्स हैं तो कितने क्वाड्रिलेटर होंगे? मैं इस क्वेश्चन को यहाँ ओपन छोड़ता हूँ आज। ओके, यू थिंक ओवर एंड वी विल डिसाइड अबाउट दिस। ओके, that is some food for thought. You think over. Okay, let's see. Do we have some time? Okay, let's see. We can see one more question. Okay, okay. Then let me ask you one more problem. How many numbers greater than 10 and less than 30 are primes? Just again, this has no direct relation with permutations. You cannot put it into a formula and find out, because I want you to, you are also doing probability, being students of class 12. So such questions will be helpful to you in finding out probabilities. So this is a question I have posed. Between 20 and 30, how many are primes? Or can you count primes from 1 to 100? You're not, nobody will ask you how many primes are there between 1 and 1000. But these small problems you can always tackle. Because suppose you are given that How many one-digit numbers you know which are primes? Okay, you think about how many two-digit number are primes? How many two-digit numbers where the digits are repeated are primes? Just think over. No? 22, 33, 44, 55, 88, 11. So there is one. Because ultimately permutations, combinations, these counting principles you have also to use for probabilities. A number of problems in probability will be based on permutations and combinations. So permutations, combinations, and continued with this is the next thing, which is uh, binomial theorem. These are very important topics from which a number of problems are asked in engineering examinations. So we'll continue with this topic again. A little bit of it. What I've given you is some exercise for home. All of you students, wherever you are, try that, and we will see a few more problems on permutations, combinations in next class, which are based on binomial theorem, and we'll pass on to binomial theorem. Okay, have a good time. Bye.
Bye, ma'am. See you. एक सेकंड मुझे पहले बता दो, ये है ना, ये कैमरे में आ रहा है ना, और वो स्लाइड के लिए है ना, ठीक है, चलो, ओके ओके. Good afternoon, everybody. Yeah, good afternoon, everybody. Today I'm going to tell you about the topic called coordination compounds. Next. When you think of coordination compound, what comes to your mind? What is it? Okay, acha, before I go to coordination compound, let me first talk of double salt. You must be familiar about simple salts, right? Simple salts like sodium chloride, lithium chloride, magnesium chloride, right? What happens to a simple salt? When sodium chloride dissolves in water, what happens? You get sodium ions and chloride ions, right? So everybody is aware about the simple salts. Now let me first tell you about what is a double salt, right? Double salt is basically a combination. For example, potash alum is a beautiful example of double salt. What is there? It is a mixture of potassium sulfate and aluminium sulfate. So in practical class, what do? We take students, we ask them to mix two solution, potassium sulfate and aluminium sulfate. They mix it and they leave it for a day or two. Next day when they come, what do they find? They find beautiful crystals of potash alum. But what is the characteristic property of potash alum? When this goes into the solution, what happens? Which kind of ions will it give you? It will give you aluminium ions, it will give you sulfate ions, it will give you potassium ions, right? Similarly, you are aware of a salt called Mohr salt, right? Mohr salt is nothing but is a combination of ferrous sulfate and ammonium sulfate. Right? So I think this is quite clear. The property of double salt is when they get dissolved in water, they dissociate into simple ions, right? Next. I was talking about a topic called coordination compounds, right? Let me tell you, till 1913, we were not even aware of what coordination compounds are. So who is the father of coordination chemistry? The father of coordination chemistry is Alfred Werner, right? He was the scientist who discovered the coordination compounds. Now, let's not see the slide and first concentrate what I'm telling you. What comes to your mind when you think of a coordination compound? Coordination compound is basically a combination of a Lewis acid and a Lewis base. What is a Lewis acid? Which need electrons, right? So what happens? All the d metal ions or transition metal ions, they are going to behave as Lewis acids. All the metals which carry a positive metal cations, for that reason, all the metal cations will carry positive charge, right? Because of the positive charge, they will behave as Lewis acids. Then you know what is a Lewis base? Lewis base is something which is capable of donating electrons. So you know this, what is this compound? What is the species called which donates electrons? It is called a ligand. You must have heard of a species called ligand. Ligand is basically a species which is capable of donating electron pair, right? So whenever there is a combination of Lewis acid and Lewis base, we always get a adduct, or we say a coordination compound. Now let me go into the history that how they came into the picture. What happened? Werner, he took cobalt trichloride and he took ammonia. And what he observed was, his point of view was, let me mix both of them and let's see what I get. So he was really surprised that he got many compounds. I have only taken two, which is, pink and yellow in nature, color, you can see. But he obtained many compounds and all the compounds were having different color. So he was a bit surprised that what is so different, because I took cobalt, I took chloride, I took ammonia. So all the compounds are supposed to be having cobalt, chloride and ammonia, right? So what was it? Now, as because you are the students of class 12, so you know what is a coordination compound. So before going to what he did, let me proceed straight away. Next slide, please. Next. 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 Yeah. So this is what you know about a coordination compound. Coordination compound basically contains a central metal ion here, which is cobalt, right? What is happening? That central metal ion is bonded to what? Ligands. Ligands are the one which are going to donate the electron pair. So central metal ion is bonded to ligands. And to how many ligands it's bonded, that's called as coordination number. The number of ligands which are bonded to the central metal ion, that's called the coordination number of the metal ion, right? Now you can see that there are few, anything which is inside the square bracket is called as coordination sphere. And these chloride ions, 3 chloride ions which you see, they are lying outside the coordination sphere. Is it clear? This is what you know, what is central metal ion. And the square bracket is indicating a complex cation, right? It is not a simple anion, because when this goes into the solution, this compound which is CONH3 whole 6, like hexaamine cobalt chloride, when it goes into the solution, which ions are you going to get? You are going to get 3 chloride ions and 1 complex ion. The complex ion is basically this is the complex cation which will get in the solution, and plus you will get 3 chloride ions. Is it okay? This is what you know about a coordination compound. But how did Werner figure it out? Can you please take me back? Yes, back. Or, yeah. So let me now discuss on what were his observations. His observations about he got compounds which had all different colors, right? Another thing, if you take ammonia in normal conditions and you put HCl to it, right? Add HCl to it, what do you get? Because ammonia is a base, it gets protonated. So you get an ammonium ion, right? But what he observed in these compounds which contained ammonia, when he took hydrochloric acid and made it react with these compounds at 100 degrees Celsius, then also nothing happened, right? So he was very surprised where this ammonia is lying. Where is this ammonia? Why is it not getting protonated by the HCl? Are you getting my point? Second thing, or let me take the conductivity. I hope there's a property of a compound called conductance. Conductance basically depends on the number of ions in the solution. Higher is the number of ions in the solution, more is the conductance, right? Yeah, conductivity, you're right. So what did he observe? That although all the compounds were having the same formula, empirical formula, but their conductance measurements were different, right? For example, next slide, sir. If you see these compounds, in the very first compound, how many ions are there in total? There is 1 complex cation, right? And 3 chloride ions. So there are total 4 ions. In the second one, which is having 1 complex cation and 2 chloride, that means 3. So the first compound was having a higher conductance or conductivity as compared to the second one. Is it okay or not? So higher is the number of, so how he made it? That these compounds which were prepared, they were different in nature because they were all showing different conductance. Is this clear? And another point was, then he made these complexes react with AgCl. He made, back sir please. Piche. Yeah. What did he do? He made it react with the silver nitrate. You might have done silver nitrate test in your qualitative analysis. What is it for? You take water extract, acidify with dilute HNO3, then you add what? Silver nitrate. If you have chloride, white precipitate is being formed, right? So what he did, he made these compounds react with silver nitrate. Depending upon the number of chloride ions, you will get, the more is the number of chloride ions, the more would be the AgCl formed. Are you getting my point, Beta? Higher is the number of chloride ions, more would be the number of AgCl molecules or the precipitate which is being formed. This is what he observed. This was his observations. By these observations, he concluded or he proposed a theory. What was it? Can you please pause? Next. Yeah. He basically proposed, that he was, because now we know what is a coordination compound. At that time, X-ray diffraction and other things were not, other techniques were not available, which taught about, which basically gave us idea about the structure of the compound. So he had a very vague idea. He basically, floated two postulates. He said there are basically two kinds of valencies or linkages in a coordination compound. The very first is primary valency, which is being satisfied by the ions which are lying outside the coordination sphere. Now, because you know what is the structure. So what was the primary valency according to him? Primary valency was basically the oxidation state of the metal, and that valency is satisfied by the number of ions which are lying outside the coordination sphere, right? Second, he said, was the secondary valency. Secondary valency is nothing but it is the number of ligands to which the metal is bonded. Like in this case, the cobalt is bonded to how many ligands? 6. So what is the secondary valency of cobalt here? 6. And what is the primary valency? 3. Because ultimately this is dissociating. That means your compound is this is your compound. That's why this is getting dissociated into this. So what is secondary valency? Secondary valency is basically the number of ligands to which the central metal atom is bonded. And it is also, now secondary valency is called as what? It is called as coordination number, right? And it is the primary responsibility of the metal to satisfy both primary valency as well as the secondary valency. Next. As I told you that primary valencies are being satisfied by the negative ions which are lying outside the coordination sphere, and ligands are going to satisfy the secondary. Next. So this is all about a coordination compound, right? Now you might have heard about, or you might have also read about the nomenclature of coordination compounds, right? And you know the rules about the nomenclature compound. Next slide, sir, please. So these are basically the rules of naming the coordination compounds. You know that the positive ion is written first. Achha, before we go to the nomenclature, I would also tell you that what are the essential requirements of that means what is a coordination compound? That means coordination compound will either contain a complex cation, right? Or it will contain a complex anion, right? Or it may also contain both complex cation plus complex anion. That means are you getting my point? The example of complex cation I gave you earlier also is when this is an example of complex cation, right? Now if I want to have an example of complex anion, what would it be? Fe, where there is a complex anion. So K3FeCN6, right? If I particularly talk of the anion, it would be this, right? And then we'll discuss later on that there is also a coordination compound which is a combination of, there can be a complex cation or a complex anion. Is it clear? Now when we know what is a complex or a coordinate compound, let's go through the rules of how to name them. The very first thing is you have to always name the positive ion first. Like for this, in this case, you have to name The complex cation, whether the cation is complex or not complex. Always our job is, or the rule says, we have to always name the cation first. Then is the ligand is always written before the metal, right? Then if there are more than one ligand, then we say it's mono, di, tri, tetra, right? Then if the ligands are negative, like chlorine has a negative charge, iodine, then all those ligands would be ending up in O, chloro, oxo, fluoro, nitro, right? But it is not, achha, one more thing. The ligands can be of three types. They can either be negative, they can be neutral, and they can be positive. The example of negative ligands, you know, chloro group, hydro, bromo, right? Oxalato. Neutral are amine, NH3, H2O, right? These are, or ethylene diamine, right? They are the example of neutral groups or neutral ligands, but they're also positive. This is also one more thing. Any species which also has a positive charge is also capable of donating the electron. For example, next slide, please. NO plus, there can be positive ligands also, and those ligands are basically, so this is an example of a positive ligand. Is this okay? Now, coming back to the rules, the ligands are, which are having the same charge, are supposed to be named in the alphabetical order, right? The oxidation state of the metal has to be put into the bracket, or in, it should be mentioned in Roman numerals, right? Then when the symbol of the metal is derived from its Latin name, and it is the component, if the metal is the if the metal is a part of complex cation, then its name and ends as it is. Let it be cobalt, it will end as cobalt. Chromium will end as chromium. But if the transition metal is part of a complex anion, its name will always end in ate, chromate, nickelate, platinate. Is it okay? Next. When I'm talking of ligand, it is also very important. You might be knowing all simple ligands like, you know, chloro, fluoro, bromo, iodo. I would also like, I'll take this opportunity to tell you there are ligands which can be, monodentate ligand is the one which donates one electron pair, right? Bidentate means which donates two, then tri, then tetra. So EDTA is a very good example, and it is a hexadentate ligand. EDTA is a hexadentate ligand. Ethylene diamine is a bidentate ligand, right? Next slide, please. As I've discussed basically Werner theory, what I'll be doing, I'll be discussing a topic and then I'll go to the MCQs. So the topic also becomes more clear when we discuss the MCQs, right? For example, the very first question is the 1 mole of a complex compound. What is the compound? CO, 5 molecules of ammonia, 3 chlorine atoms, gives 3 moles of ions on dissociation in water. 1 mole of the same complex reacts with 2 moles of AgNO3 solution to yield what? 2 moles of AgCl. What is the structure? Can you guess the structure? How do you reach to the conclusion? The very first thing which you have to understand that this is the empirical formula. CO, NH3, 5, Cl3. In this, we have no idea what is inside the coordination sphere and what is lying outside. How many? What? So usually, what is the idea or what is the way to go behind it? The thing is, always a neutral ligand will fall into the coordination sphere. We will always put a neutral ligand into the coordination sphere. That means if I start like this, all these ammonias are going to be inside, right? Let's leave the chlorine right now. Now 1 mole of the same complex is reacting with 2 moles of AgNO3. So 1 mole of compound is reacting with how many moles of AgNO3? 2 of them, right? If one chloride will react with one AgNO3, if 2 moles of AgNO3 are being consumed, that means how many chloride ions are there? There are 2. So if there are 2 chloride ions, that means they should be ionizable, because we will only get chloride ions when they are ionizable. They will only be ionizable when they are lying outside the coordination sphere. So how many of them are there? 2. So what I can do is I can place 2 chlorine ligands outside the coordination sphere. Now what I'm left with? I'm left with only one Cl which I can place here. So what is the structure? The right answer would be, so A can be, we can neglect A, B and C. Why? The very first thing is because ammonia is lying outside. And as I told you, whenever you get these kind of MCQs, the key is that you place the neutral ligand always inside the coordination sphere. Right? Is this clear? So because when this will dissociate, it will basically give you right? So it will only furnish 2 chloride ions. These 2 chloride ions will react with 2 moles of AgNO3. Is this okay? Let's go to the second one. What is the second question? It says that both cobalt 3 plus and platinum 4 plus have a coordination number of 6. Which of the following pairs of complexes will show approximately same electrical conductance for their 0.001 molar aqueous solution? So which property are we talking about? We are talking about electrical conductance. On which this conductance is dependent? This depends upon the number of ions. Higher is the number of ions, higher is the electrical conductance. And what is it saying? That both the metals are having the coordination number 6, right? So what we will do, any guesses how to go about this? Let us take A. Let's take one by one. Yeah. As I told you, you can always place the neutral ligand inside. So it is the very first one I'm talking of is 4. You're left with Cl, 2, and 1 Cl is outside. And this we can make platinum. Again, because the coordination of both the compounds is, the coordination number is 6. So obviously there should be 6 ligands inside the coordination sphere, right? Let's quickly write down what else is possible for the other ones. Right? C is again now D would be E is now let's take them. What we have to compare, that which of the pairs would be having the same electrical conductance. Only those pairs would be having the same electrical conductance which will be having the same number of ions. So in this, how many? This will dissociate into 2. What about this? This will be dissociated into 3. That means these two cannot be having the same electrical conductance. So this cannot be our answer. Second, what about this? Can this be? Because this is a single. What about this? This is going to furnish 4. So even this can't be. What about this? 4, 1 complex cation, 3 chloride ions. Again 1 complex cation, 3. So the number is same. So this should be our answer. Is this clear, beta? Because when this goes into the solution, it's going to furnish 4 ions. The number of ions this compound is going to furnish is 4, and this is also 4. So if the number of ions are same, obviously their electrical conductance would also be same. So your answer would be C in that case. Okay, next. Now let's take this question. The primary and the secondary valencies of chromium and the complex ion dichloro-dioxalate of chromium are. What do you think is the answer? See, what is the primary valency? Primary valency is the oxidation state. So what is the oxidation state of chromium? 3. So this is very straight because you have the oxidation state in the Roman numerals. So you know the primary valency is 3. That means the answer can be A or C. Now coming to the secondary valency. Secondary valency is nothing but it is the number of ligands to which it is bonded. How many ligands are there? There is, although there are 2 ligands of chlorine and then is oxalate. But then you know that oxalate is a bidentate ligand, right? So if we talk of the compound, it would be like chromium, right? 2 chlorines, oxalate, because it's a bidentate ligand. But what happens? The coordination number of chromium is what? It is 6, because there are 2 bidentate ligands and 2 monodentate ligands. Is it clear? So the answer of this would be C. Okay. Next question. The next question says, the next question says that ammonia forms the complex ion tetramine copper with copper ions in alkaline solution, but not in acidic. Right? Actually, before I go to this question, let me tell you one thing. If there is a complex compound, what do you think what happens when a coordinate compound dissolves in the solution? For example, if I have this, suppose this is the compound, right? This is a coordination compound. Will this compound give the test of chloride? It will definitely give, because when because these are the chloride ions which are lying outside the coordination sphere, right? Do you think it will give you the test of ammonia? No. Why? Because ammonia is not available outside. It is inside. So this will not give you the test of ammonia. That means what is the characteristic property of coordination compounds? That when they dissolve, that doesn't mean that they'll give the positive test of their constituent ions, right? For example, instead of this, if I have inside a nitro group or a chloro or a fluoro or an ido, right? Ligands. Do you think if they are lying inside the coordination sphere, they'll give the test of this? Only the ion which is lying outside, only that would be giving the positive test, right? All the ions which are lying inside, they will not be giving any kind of test because they will not be going into solution. They will be going as whole as a complex ion, right? Now coming back to the question, ammonia forms a complex ion, this with copper ions in alkaline solution, but not in acidic. What can be the reason for this? Tell me, what do you think is the answer of this? Let's take D first. In acidic solution, hydration protects copper ions. I don't think so. That should be the answer. Hydration has nothing to do with this. C is copper hydroxide is an amphoteric substance. If copper hydroxide is first of all, it is not amphoteric. If it's amphoteric, then also it doesn't affect. So the answer is basically A, because what is the possibility that in acidic solutions, the ammonia, because I don't know if you, I think it is not there in the syllabus of Cbse, but still it is asked in the entrance that the structure of tetramine copper sulfate, right, is tetragonal in nature. That means it is not a very stable octahedral complex. Rather, it is a distorted octahedral which gets transformed into a tetragonal structure. So if you, instead of alkaline conditions, if you use acidic conditions, in that case, what is the possibility? The first possibility, that the ammonia may get protonated, because the bonds are not proper octahedral, it is weakly bonded. Therefore, the ammonia which is present inside the coordination sphere, there is a possibility that it gets protonated into ammonium ions. Next, sir. Okay. Now, when EDTA is added to magnesium 2 plus solution, then which of the following statement is not true? 4 coordinate sites of Mg are occupied, Mg2 plus are occupied by EDTA, and remaining 2 sites are occupied by water molecules? No, because EDTA is what? What kind of ligand is EDTA? It is a hexadentate ligand, right? So it is not possible that it is coordinating only 4 of the sites, right? Second is, all the 6 coordinate sites of Mg2 plus are being occupied, which is true because EDTA is a hexadentate ligand. Third is, the pH of the solution is decreased. Okay, and the colorless Mg chelate, you know, I hope everybody knows this, that ligand which is having more than bidentate ligands, tridentate ligands, tetra, penta, or hexadentate ligands like EDTA, they form certain compounds which are called as chelates, right? They're called as chelates. Chelate is nothing but a structure which is having a ring, right? Now, similarly, coming to the next, which of the following ligand possess only one coordination site? What do you think? What is the coordination site through which the donation of electron takes place? What is the coordination site, beta? Through which the electron donation takes place? Now, let's take the example of carbonate. What is the structure? There are 2 oxygens which are carrying negative charge. That means there are 2 donor sites. Similarly, let's take sulfate. Right? 2. So, number of sites here is 2. Again, here is again 2. Oxalate, you know. Oxalate is, again, it is having 2 sites. So, the only one which is left is oxo. Right? So, the answer would be B. The answer would be B. Although, let me also remind you one more thing. Although carbonate ion is having 2 oxygens, but still it would be only engaging one of the oxygens, because it is not a bidentate ligand, right? It is a monodentate ligand. Only one of the oxygens would be involved. The reason for that is, if both of them would be involved, the angle strain would be too less. So it is only observed that the carbonate ion forms complex only via one coordination site. Similarly, sulfate, although have 2 oxygens available, but the complex will only be found from one of the oxygen. The coordination site would only be one oxygen. Is it okay? Oxalate, you know, and this can coordinate from both, because obviously in this there is no factor of angle strain. Is this clear? Next, please. Okay, now let's take this. The coordination number and the oxidation state of the element E in the complex E ethylene diamine, then this is C2O4 is in oxalate, NO2 is lying outside the coordination sphere. So what do you think is the oxidation state of the E? Tell me. I hope everybody knows how to find out the oxidation state. See, how do we, let's put it, X, right? Ethylene diamine is a neutral ligand, so it does not have any charge. What about oxalate? It is having, and how many oxalates are there? Only 1. So minus 2. And what is the charge? Because outside is NO negative. So obviously this should be having 1 positive charge. Are you getting what I'm doing? So this comes out to be X plus 1. So X comes out to be So oxidation state is 3. That means the answer can either be A or D. What about the coordination number? Coordination number is 6 because what are the ligands? Ethylene diamine is a bidentate ligand. So 4 of the coordination sites would be, satisfied by that. And then you have a oxalate. It is a bidentate ligand. So the coordination number is 6. So what is the answer? The answer is A. Coordination number 6 and the oxidation state is 3. Now let's take another one. Can you tell me in these complexes what is the coordination number of iron and chromium are? In the case of iron, the ligand is monodentate and that's cyanide. What about chromium? The ligand is bidentate. So what do you think should be the coordination number? So if I try to make a diagram, the coordination number of iron is 6, right? What about chromium? Chromium would again be 6 because how many? 6. Oxalate is there. Oxalate is a bidentate ligand. So one oxalate will satisfy 2 coordinate sites. So 3 oxalates are there. That means they'll be coordinating 3 through 6. Therefore, the coordination number of chromium would be 6. So what would be the answer? The answer would be B. Next, please. Next. Now let's quickly, because when we do these questions, we'll also brush up our rules also. The first is IUPAC name of this complex. What do you think would be the answer? First, we have to name the neutral ligand or what? Alphabetical order? Alphabetical order, no? So what will name? Triamine. Then is bromo. B for bromo. So it will be triamine, bromo, chloro, nitro, platinum. Because when you are taking platinum, platinum is the one which is lying inside the complex cation. The cation is the one which has to be named first, right? I hope you know this. The outside is Cl. That means this is having plus 1. And what does the rule say? That we have to name the cation first. In cation, we'll take the ligands in alphabetical order. Therefore, the answer would be triamine, bromo, chloro, nitro. Because this is platinum is a part of a complex cation. Therefore, platinum would be named as platinum, not as platinate. And in bracket, we'll give the oxidation state. How do we calculate the oxidation state? -1, -1, -1 is equal to +1. This comes out to be 4. So what is the oxidation state of platinum is 4. And outside is chloride. So the answer is C. Next. What do you think is the answer? Next question. So back please. What do you think is the answer of this? Which is the cation? Now the coordination compound is having a complex anion, right? The cation is sodium. That means the complex anion is having a 3 negative charge on it because there are 3 sodiums, no? Right? So your complex anion is 3 sodiums make it here 3 negative. Because sodium is the cation, will name sodium. So the name will start with sodium. How many are the ligands? Hexa, nitro. Because this is a part of a negative ion, so we'll say it cobaltate. What is the oxidation state? X minus 6 is equal to -3. That comes out to be +3. So what is the answer? C. Sodium, hexa, nitro, cobaltate. Next, please. Is this clear? Now, can you tell me the answer of this? The name is dibromo bis ethylene diamine. That means 2 bromines are lying inside the coordination sphere. That means it can't be A, right? It can't be A, it can't be C because bromine, it is dibromo. And in the first case, the bromo group is not inside. And in the C, or the bromine, how many bromo groups are there? 4. So A and C are ruled out. So what we are left is B and D. Now what is the name of the compound? Dibromo bis-ethylene. How many? In B, how many ethylene are there? Ethylene diamine group? 2. And in C, how many? 1. So the answer is B. Yeah. The answer is B. Is it okay? Next. Now what about this? Dichlorodimine platinum complex has formula this. Which of the compounds satisfies this formula? See, the very first thing, what will you observe is, it is a coordination compound, so the platinum has to fall into square brackets. So A can't be the answer, right? B can't be the answer. What about C and D? In C and D, you have to see, it is diamine. That means the ligand is ammonia. It cannot be that RNH2 whole twice, right? So the only answer you are left with is C, right? Next. Next. And this you have to calculate, what is the oxidation state. In which of the following complexes the oxidation state of metal is 0? It is? How do you reach to the conclusion it's B? CO is a neutral ligand. And moreover, when you will calculate this, because this is having 3 chlorides, X minus 3 will obviously, So if chromium is having a neutral ligand and it is only associated, metal carbonyls वैसे भी, for your knowledge I'll tell you, most of the metal carbonyls, they exist in the metal with the 0 oxidation state, right? Next, please. Now, what do you think? Achha, this is important because in entrance, you usually, that's why I've taken this example. In this, how will you start naming the compounds? This is an example where both your complex cation and complex anion are involved, right? How would you do it? Tell me. In this, the only rule which you can follow is, first thing is, what are the most common oxidation states? Platinum basically exists in 2 common oxidation states. One is +2, other is +4. The key is platinum and palladium will always exist in +2 and +4. Now let's start, because we don't have any idea. Let's put 0, 0 here. Suppose the charges can be 0, 0. No, because it's compound. One should be having a positive charge and other should be having a negative charge. Suppose I put +1. Let me put minus here. Minus and plus. Now what happens here? Oxidation state X minus 2 is equal to -1. X comes out to be +3. This can't be because platinum can't be in +3 oxidation state. Similarly here, X minus 4 is equal to plus. This goes to be 5. This also not possible because platinum cannot have an oxidation state of 5, right? So what will we try? Now we'll go to minus. Initially I had put minus here. Let me put plus here and minus here. Now let's do it. X minus 2 is equal to +1. Again, what happens? The oxidation state is +3. Is it possible? No. So what will we do? Let's increase the charge. +2. If this is +2, obviously that has to be -2 only. Then they can form a coordination compound being complex cation and anion, right? So X minus 2 goes to, this comes out as 4, which is fine because platinum has in 4 oxidation. Similarly here, let's do it from -2, right? X comes out to be, platinum is existing in a 2 oxidation state, right? So this is a complex cation. So we'll be naming this first. Let's start. What do you think is the answer? Tetramine dichloroplatinum. What is the oxidation state of platinum? 4. And that is tetrachloroplatinate. The oxidation state is 2. So the answer to that is A. Let's go to the next. Can you find out what is the answer? Again, I'll tell you, nickel will only exist in a 0 oxidation state or a +2 oxidation state. Only 2 states are possible, right? So, and moreover, nickel here is having a neutral ligand. So if we place 0 here, then obviously this compound can't exist because there has to be some charge. This is a coordination. That means this cannot be 0. So the other possibility is nickel is in which oxidation state? +2. This is a neutral ligand. That means the +2 charge has to be here. If this is +2, this becomes -2, right? How would we name it now? It would be tetraamine nickel. Oxidation state is 2, and this would be tetrachloronickelate. With oxidation state, what is the oxidation state here? So in both the cases, the oxidation state is 2. So what is the answer? It is C. Is it clear? Next, please. So till now, I have basically discussed Werner theory, in which I have explained very clearly that what is the oxidation state, what is the coordination number, what is the primary valency, and what is secondary. So I hope now you'll be able to attempt all the questions on this and also on the nomenclature, because I've taken all the examples of complex cation, complex anion, a combo of them, right? Now let's go to the bonding. Let's talk about how do the bonding takes place in coordination compounds. Do you have any idea about it? You might have heard about a theory called valence bond theory, right? What happens in valence bond theory? What happens in it? There are valence orbitals, they hybridize and they give you new set of orbitals. And also valence bond theory, you might have also heard, like sp, the shapes is, if the hybridization is sp, the shape is linear. If it's sp2, it's trigonal planar. If it's sp3, it's tetrahedral, right? sp2, sp3 is tetrahedral. Then it would be d, sp2, it would be square planar, right? It can be d2, sp3, that would be octahedral, and also sp3, d2. So I would be basically discussing, because usually the coordination compounds, the metal usually have a coordination number 4 or a coordination number 6. Whenever it is having a coordination number 4, what would the geometry? The geometry would either be tetrahedral or it would be square planar. And if the coordination number is 6, then the octahedral, right? Now in this case, I have taken the example of hexamine cobalt. Now as you can see, what is the oxidation state of cobalt here? It is +3. The oxidation state of cobalt, because ammonia is a neutral ligand, right? So the oxidation state of cobalt is +3. In the ground state of cobalt, how many electrons are there? Total 27 electrons are there, right? So what is cobalt in ground state? It is 3d7, 4s2. Now what is the oxidation state of cobalt? It is +3. That means you are only left with 3d6. Now what happens? Now if it wants, what is the coordination number? It's 6. So it needs to form bond with 6 ligands. What is the job of the ligands? To donate the electron pair in the vacant orbital and form a coordinate bond, right? Therefore, what cobalt needs? It needs to furnish or make available how many orbitals? In total, 6, in which the ammonia can donate the electron pair and a bond can be formed, or this coordination compound can be formed. Now talking of 3d6, when you draw 2, 3, 4, 5, and this is 6, right? Now, as you might have read in class 12, that ligands are also of 2 types, strong field ligands and weak field ligands. Ammonia is a strong field ligand. So what does it does? It causes the pairing. So the 6 electrons which are there in cobalt, they all get paired up. When they get paired up, there is always an availability of 2 d orbitals which are vacant, right? Now, so what is this cobalt doing? It is using these 2 d orbitals, the 4s orbital which is empty, and 3 4p orbitals which are empty again. So in total 2 d orbitals, 1 s, 3p. Total how many orbitals? 6. And the kind of hybridization would be d2sp3. Is it okay? So shape of the compound would be octahedral and they're also called as inner orbital complexes. Why are they called as inner orbital complexes? Because the d orbital in D2sp3 is the d orbital which is the valence shell, right? What is the valence shell? It's 3D. So if it is using the d orbital of this valence shell, like for example 3D here, if the 3D metals are using 3D and 4D are using 4D or 5D are using only their 5D, then we say they are going to form inner orbital complexes. But suppose a 3D metal uses its 4D orbital, then what are they called? They basically are called as out. I'll take the example also, but this is an example of inner orbital complex, right? Next. Similarly, this is nickel, right? In your CBSE textbooks, NCERT में, you might have read that all the cases which VBT has taken, none of the cases is below D5. All the cases in your जो आपके क्लास में diagrams बने हुए हैं CBSE की books में, सब D6, D7, D8, D9 बने हैं. The reason for that is the VBT fails whenever the electrons in the d orbitals are below 5, right? I'll tell you about the disadvantages also, but let me take this. Is it clear from this diagram what is an outer orbital complex? What is happening? Pairing is being caused, but only one d orbital is available, right? So what happens? Nickel takes 2d orbitals from the 4d, but nickel ka valence shell kya hai? The valence electrons are lying in 3d. So if it's taking 4d orbitals and making an octahedral complex, then what do we call them? We call them outer orbital complexes, right? Next, please. Last पे रहने दो, I'll discuss VBT. What was the drawback of VBT? VBT का drawback ये था that it doesn't tell us about the magnetic moment, right? We don't have any clue. At times when we draw the structures, then we think, oh, the magnetic moment should be so much. But then it was not correlating well with the experiments and the observations, right? Second was VBT could not explain the DD transition, or you can say electronic spectra of these coordination compounds were not explained by VBT. Why it was not explained? I will do it when we'll do the MCQs, then I'll discuss. That time, this way will save time also. Now the beta theory, which is, what is it called? Crystal field theory. But first you have to understand what is crystal field theory. In crystal field theory, the metal is treated as a positive charge and all the ligands are treated as negative charge, right? They are treated as negative point charges. Ammonia is not a molecule. Ammonia is a negative point charges because what is its job? It is floating around with a pair of electrons, which is going to donate to the metal. So metal is basically viewed as a positive charge and the ligands are viewed as a negative charge. So this is the primary thing, right? Second is whenever opposite attracts, so if the metal is having the plus charge, the ligands are having the negative charge, they are bound to attract and they are bound to form what? Bond, which you already know the kind of bond they form is coordinate, in which the ligand is donating the electrons to the metal, right? Now in this whole process, what happens? There is a metal. Metal is although having a positive charge, but it is still having what? Electrons in it, 1s, 2s, 2s, 2p, 3s, right? So there are electrons residing in the metal also. More important, coordination compounds are formed by what? Transition metals mostly, and the reason for that is because they have 3d orbitals, right? So 3d orbitals are also having some kind of electrons in them. It can be d1, d2 configuration, d3, d4, d5, right? So when electrons are approaching the metal ions, right? When a complex is supposed to be formed. Next slide, please. I'll show you. Yeah. This is the shape of d orbitals, you know, dyz, dzx, dxy. These are the two, right? Next. Now what happens? This is what I'm going to show you. When the ligands, now metal is in the center, right? And the ligands are approaching it. Ligands are supposed to approach it because there's an attraction of plus and minus and then form a bond with metal, right? As you can see in this picture, this is dz square. A ligand, if it's going to form an octahedral complex, it will approach from here and here, right? if the approach is from here and here, this is dz square orbital, the repulsions would be maximum. ये जो d orbital है, अगर उसके अंदर electrons हैं और ligand यहाँ से approach कर रहा है, so obviously ligand is also having electrons, and these d orbitals are also having electrons, so there would be some kind of repulsion. So is also the case of what is the shape of dx square minus y square? The orbitals are lying on the axis of x and y. So ligand is going to approach from here. The orbital is also, the symmetry of the orbital is also that side. So in both these cases, what will happen? The ligand is going to face a lot of repulsion, right? From what? From the d orbitals of the metal ion. Whereas in the case of dx, z, y, z and these three, as you can see, these are, the shape is like this. And the ligand is approaching. So they are falling in between. That means there is no head-on repulsion there. So in these, what happens in crystal field theory, these two orbitals, because they are facing higher repulsions, their energy gets elevated. As you know, in any system, whenever repulsion takes place, the energy of the system increases. And whenever there is an attraction in the system, the energy of the system decreases. So because dz square and dx square minus y square, they lie exactly in the path which the ligands are going to take, the number of repulsion is higher. It's more. Whereas these are not in the path. As you can see in the figure, it's here like this, and the ligands are approaching like this. So the repulsions are not very high. So what happens? Next, please. So the repulsion between the ligand's lone pair and the d orbitals of metal, what happens? They result in a splitting. When we say splitting, what do I mean by that? Forget that the ligand is approaching the metal. Just imagine the metal atom, right? What is the state of d orbital? All the d orbitals are degenerate. When I say degenerate, what is the meaning of it? They are having all same energy, right? Now what happens? Ligand approached two of the orbitals, which is dz square and dx square minus y square. That showed a lot of repulsion. That means the energy of those orbitals would be increased, whereas those which didn't show any kind of repulsion, there would be a decrease. That means the degeneracy of the 3d orbitals would be lost. Now no more all of the 5 orbitals will be having the same energy, right? Next slide, please. Now what happens? Because the ligands approach the metal and there was a repulsion and attraction between the d orbitals, what happens? Because xy, yz and xz didn't face any kind of repulsion, their energy is lowered. And here, because they had strong repulsions from the incoming ligand, their energy is increased. So now the d orbitals get divided into this 3 sets and these 2 sets. This is basically called as T2g orbitals, and the higher one, next please. And the next is basically called as EG orbitals, right? This is T2g and this is EG. And the separation between T2g and EG is delta naught, right? Is this clear? Or shall I repeat this? Is it clear to everybody? That means initially I had this is EG, okay? Initially all the 5 orbitals were what? They were degenerate. They were at same energy level. They got split. Now this splitting is called as delta naught, right? But in some of the books, delta naught is also termed as 10 dq. In most of the question papers, you'll see 10 dq also. 10 dq is also meaning the same thing. This O is indicating the octahedral field, right? This is called as crystal field splitting energy, CFSE, yeah. dq. That's basically a symbol used for the CFSE splitting. That's equal to 10. For example, I'll give you what is it meant. How much is the lowering factor here? It is 0.4. Here is 0.6. So what will we say? The lowering is by 0.4 delta naught, right? But when we'll talk of dq, then we'll say the lowering is 4 dq. Same, this is 0.6 delta naught. But when we talk in terms of dq, it would be 6 dq. Is this okay? Is it clear? Shall I proceed? So this is the kind of splitting which occurs in octahedral field. When I say octahedral field means when a metal is being approached by 6 ligands and an octahedral complex is being formed. Next, sir. This is what I told you. In some of the texts you will find 6 dq, 4 dq. In some you will find 0.4 delta naught, 0.6. But this is always in a negative because the energy has been lowered, and this would be positive because here the energy has been increased. Is this okay? And this CFSE splitting or delta naught or 10 dq is different for different complex. The CFSE splitting, CF crystal field splitting energy or the delta naught or 10 dq is different for all the different complexes. What are the key factors? What kind of ligand is it? Stronger is the ligand, more would be the splitting, right? If the ligand is very strong, it will cause more splitting. If the ligand is weak, there would be less of splitting. Second is the oxidation state. Higher is the oxidation state of the metal, more would be the splitting. Lower is the oxidation state, less would be splitting. And one more factor which plays an important role is 3D metals would be having low splitting, 4D would be having, if a coordination compound is involving a metal from 4D and metal from 3D, then obviously the one which is having a 4D metal will have a higher dq value or a delta naught value. Similarly, if one metal is from 4D and other is from 5D, the one which is from 5D will have a stronger field splitting as compared to 4 or 3. So these are the 3 crucial factors which affect the d orbital splitting. Next, please. You might have also done this, depending upon what is, all the ligands are having different strength. So this is basically giving you an idea about the stronger ligand here is carbon monoxide, then is, as you can see from the order. Next. This is an example I have taken, that how, what does the color indicate? Now, what does the color indicate for you? Color basically indicates, see in this I've taken an example. The central metal ion is 1. What is it? Cobalt. The central metal ion is cobalt. Cobalt is the one which is common in them A, B, C, D. You take any complex. The only thing which is varying here is the ligand, right? Now you know what is Vibgor, violet, indigo, and all. Okay? So what is the energy? Energy of violet is the highest, red is the lowest, right? That means if the energy of violet, blue is the highest, that means there what is happening? The splitting is high, right? And this is why crystal field theory, it explains the electronic spectra. How does it explain? Because if the electrons are in T2G, what happens? When you give energy, they get excited to the higher energy level, which is EG orbital. And when they come down, they emit the radiation which they had absorbed, which falls into the visible region. Now, depending upon the strength of the ligand, suppose the strength of the ligand is very high, the splitting would be very high. That will give you around violet color or indigo color. But suppose the splitting, the field strength of the ligand is low, the splitting would again be low. If the splitting is low, that means the energy barrier or the energy difference between T2G and EG would be low. That will give you a color which is nearer to red or orange. Now, do you get what does these color indicate? These colors are basically indicating about the kind of ligand. Stronger is the ligand, more is the delta naught or more is the splitting. Next, please. Now this I have taken, strong ligands always form low spin complexes. When I say low spin, that means the magnetic moment is low or 0. Or you can say if the magnetic moment is 0, then we say those complexes are called as diamagnetic. So what is the job of a strong field ligand? What does it do? What is the trait? The trait of a strong field ligand is that it does pairing in T2G orbitals. Whereas a weak field ligand, it can, suppose H2O, if we compare H2O to cyanide or cyano group, Cyano group is a stronger ligand than H2O, right? Because cyanide is a strong field ligand, what does it do? It is capable of pairing FeCN, this complex. What is the oxidation state of iron? H plus 2. Plus 2 is D6. D6 means all the electrons, there are 6 electrons and all the electrons get paired up here. Now if we take aqua or H2O group, it is a weak field ligand. Although there also the oxidation state of iron is plus 2. But because H2O is a weak field ligand, it doesn't do the pairing. So in that case, how many unpaired electrons do we get? We get 4 unpaired electrons. And therefore this becomes paramagnetic. So those complexes in which the magnetic moment is low, those are low spin. Where there is magnetic moment is high, then we call them high spin. Is this clear? So always a strong field ligand will form a low spin complex and a weak field ligand will form a high spin complex. Is this clear? Next please. Okay, just a minute, previous one. Actually, one more thing. There would be no high spin, a strong field ligand or a weak field ligand will not make any difference in D1 case, D2 case or D3, because in D1 also T2G1, D2 T2G2, D3 T2G3. The only factor which comes into play that whether the ligand is strong or weak is D4, D5, D6 and D7, because D8 again, D8 may all the T2G6 would be filled and then you have to fill the EG. So it doesn't make difference in D7, D8 and D9 whether the ligand is strong or weak. Similarly in D1, D2 and D3 cases also it doesn't matter whether the ligand is strong or weak. Next please. Now this is because in your syllabus I think you have only octahedral and tetrahedral. In tetrahedral it's the reverse, right? Because in tetrahedral geometry what are the shapes? sp3 hybridization hota hai na? So sp3 hybridization ka you know how they are placed in the space? In that case what happens, the maximum repulsions are because their spatial arrangement is such that they are lying in the direction of x, y and z axis. So those axes are going to face the maximum repulsion. So in that case what happens, the energy of these orbitals get higher and these two, because they don't lie in the direct path, their energy is lowered. So now this in all you can say that Eg orbital are having lower energy in tetrahedral complexes and T2G is lying higher in energy, right? Next please. Before I wind up coordination compounds and let's take question on them, let me tell you what are the application. The very first application is complexometric titrations. Complexometric titrations are all done with what? EDTA. You know what is EDTA? EDTA is a hexadentate ligand. So this is an EDTA is a ligand which is going to form complex with all the metals. Let it be magnesium, calcium, transition metals. So this is one of the very important field which is being developed and used for quantitative analysis, right? Second is qualitative analysis. You might have done qualitative analysis or mixture analysis in which you use compounds, you know, how do you detect nickel? A rose red precipitate of nickel DMG complex you get. Then copper by adding ammonia, ammonical solution gives you, you know, a deep blue complex. Then you use potassium ferrocyanide to give a confirmatory test of iron. I hope you will be using it. Then is medicines, you know, let me take the example of lead. If a person is having excess of lead in his body, doctors usually prescribe EDTA because EDTA is a good ligand. It has a tendency to bind to the metal. So EDTA is given or prescribed as a tablet or a syrup. So what happens? EDTA goes into the body. It forms the complex with the lead. And what kind of complex it would be? Obviously, coordination complex because I'm discussing coordination compounds, right? Cisplatin, as you know, cisplatin is one of the anti-cancer. Let me tell you, this is very important. It is the first anti-cancer drug which has been developed. It is again a coordination compound. The structure is this. This is the common name of, what is this? This is cisplatin. This is basically, what is this? This is again a coordination compound, right? A square planar complex. It is used as anti-cancer drug. Then you know what are the roles of metal ions in biological system. Chlorophyll. Chlorophyll is having what? Magnesium. Again, you know, with coordinate bonds in it. Hemocyanin is containing iron. Carbonic anhydrase is containing zinc, and vitamin B12 contains cobalt. So these are basic application of the coordination compounds. Next, please. Next. Now what we'll be doing, we'll be doing the questions on this. Valence bond theory as well as CFT, so that both the theories become more clear to us. Can you please read out the first question? Nickel is the central metal ion. Two chloro groups are the ligands, and the third is triphenyl phosphine is the ligand. What is the ligand? Triethyl phosphine, right? They are exhibiting temperature dependent magnetic behavior. What is the magnetic behavior? Paramagnetic and diamagnetic. When we say paramagnetic means availability of single electrons, right? Unpaired electrons. Diamagnetic means electrons are totally paired. Now the coordinate geometries of nickel in paramagnetic and diamagnetic states are respectively what? So what do you think? What should be the shape? First let's take nickel. What is nickel plus 2? It would be, what is nickel in ground state? It is 3D8 4S 2 plus 2 would be 3D8. Let's use VBT first. So how many electrons are there? 8. 1, 2, 3, 4, 5, 6, 7 and 8. Right? Now, how many ligands are there? 4. There are 4 ligands, no? 2 chlorine, 2 those. There are 4 ligands. That means the coordination of nickel would be 4, right? If the coordination number of nickel is 4, how many hybridized orbital it has to furnish? 4, because obviously if there are 4 ligands, they need 4 vacant d orbitals, right? In the first case, what is it? Paramagnetic. What do you think can be the case of paramagnetic? When both these electrons are free. That means the ligands are donating electrons in 4s and 4p, and d orbital remain as it is with singly filled electrons here. That means when the complex would be sp3 type, or it would be tetrahedral, in that case what? It would be paramagnetic. So where is tetrahedral? Either A or C. The first complex has to be tetrahedral if we are considering the magnetic moment. What is the second possibility? Diamagnetic. When do you think this will get diamagnetic? What will happen? Tell me. If the pairing occurs, then this d orbital is available, right? Now 1, 2, 3, 4. So what kind of hybridization? DsP2. So what is the geometry of DsP2? It is square planar. So what are the answers? The answer would be tetrahedral, and this you have to see, work it out. Like in the square planar geometry, it is coming out to be diamagnetic, and in this it is coming out to be paramagnetic. So your answer becomes C. This is tetrahedral and square planar. Next, what is it? No, next question. What is the next question? Which one of the following cyno complexes would exhibit the lowest value of paramagnetic behavior? First, let's take the metals. I told you VBT fails, which is a better theory for magnetic moment? CFT. So let's take the first. What is chromium? What is the oxidation state of chromium? +3, right? So +3 means what? How the electrons would be? The electrons are 1, 2, 3. Second metal is, what is the oxidation state again? Plus. See, so it comes out to be, what is it? This is D3 case. What is Mn +3? It would be how many electrons? D में कितने electrons है please बताएं? What is the atomic number of manganese? 25. That means how many electrons? 3D and 4s. I want the configuration in 3D and 4s. It is 3D5, 4s2. So if the oxidation state is, so it comes out to be D4, right? So 1, 2, 3. And what kind of ligand is cyano group? It is a very strong field ligand. So what the cyano group will do? It will cause pairing, right? Now let's take the example of Fe. Fe, what is the sign? Oxidation state? +3. What is +3? It is 4d6, 3d6, 4s2. So it comes out to be 3d5. Now if we take 3d5, strong field ligand, so we don't have to consider Eg orbitals at all. We'll only consider the T2G orbitals. And let's take the case of cobalt. Cobalt would be again +3. It would be D6 case. So all the electrons in T2G would be paired up. So what do you think? Which of the compounds will give the maximum magnetic moment? The one which is having the maximum number of electrons, unpaired electrons. Which one is that? This is having no unpaired electrons. Here only one electron. Here 2 and this is 3. So the answer should be. नहीं तो lowest पूछा है तो क्या होगा answer? It would be D. So the answer would be D, right? Which will be having how much? It will not be paramagnetic. It would be 0. The magnetic moment would be 0 because there is no availability of electrons, unpaired electrons. Next, please. Now let's take the question. The octahedral complex of a metal ion M3 plus with 4 monodentate ligands, right? Absorb in wavelength red, green, yellow, blue. As I told you earlier, what is the light color indicating? It is basically indicating the energy, right? So what do you have to find out? You have to find out the ligand strength, right? L1 is absorbing what? Which wavelength? Batao? L1 is absorbing in red, L2 in green, L3 yellow, L4 blue. So that means the highest splitting would be where? It would be. So what would be the strength? So highest would be. Tell me. Can you guess? Wib Gore. Blue, then green, then yellow, then red. So what should be the order? L4, then L2, then L3. So the answer would be B. Are you understanding? How can you relate the color with the strength of the ligand? Is this okay? Next question. Which of the following complex would be having the least stability? What do you think can be the answer? Okay, let's compare first. All the 4 is having cobalt in them, right? All of these, let it be cyano group, let it be carbon monoxide or ammonia, all of these fall into the category of strong field ligands. So strong field or the strength of the ligand is not a factor which is playing a key role. Cobalt is same, that means cobalt is, what do you think? What is the oxidation state of cobalt here? +3. Here, again +3. Here, what about this? +2. So what is different? Oxidation state of cobalt in 3 of the complexes is +3 and in one of them is +2. Higher is the charge on the metal, more is the bond stable. Because if higher is the charge, more strongly it will attract the ligand. Shorter would be the bond length, right? And if there is less charge on the metal ion, what will happen? There would be less stable because it will not be able to hold the ligand tightly because the positive charge on it is less. Is this clear? Is this clear? Here you have to differentiate among the oxidation state on the metal. Higher oxidation state will always form stable complexes. Lower oxidation will form less stable complexes. Next, please. Now, what is the magnetic moment for this? Can you do it? Yes. Which is a better theory for magnetic moment? CFT. So what is the oxidation state of iron here? It is? What is +3? It is 3d5. There are 5 electrons. And what kind of ligand is fluoride? It is weak field. That means pairing will occur or not? So the pairing will. So how many electrons would be there in total? There would be 5 singly filled electrons. And you know what is the formula for magnetic moment? It is n plus, where n is the number of unpaired electrons. So if n की value is how much? 1, 2, 3, 4, 5. So 5 into 5 plus 2 is 7 into 35. So almost square root of 35 comes out to be. Is it okay? Whenever there is a question on magnetic moment, the best way to solve it is to use CFT. And when you use CFT, please keep into mind that what kind of ligand it is, strong field or weak field. Okay, let's take the other one. The hybridization states of tetracarbonyl nickel, tetracyanonickel, and this. What are the hybridization? Can you guess? First thing, in all the complexes, the coordination number of nickel is 4, right? Now tell me what can be the answer? The answer is nickel tetracarbonyl is tetrahedral. So sp3, nickel tetracarbonyl is tetrahedral, so it is sp3. What about nickel, sir? It is square planar. And again nickel tetrachloride is tetrahedral. So the answer would be D, right? Next please. Now again, the complex which will have the highest magnetic moment will be able to do this. You can take out what are the oxidation state. What is it? It is D6, D5, D3. Then you can use CFT. You can also consider what? Because in the case of fluoride, it is the weakest ligand. So in that case, pairing will not occur. So considering that cyanide and ammonia will cause pairing, according to that, you make the CFT diagram and then calculate the magnetic moment. Will you be able to do so? Now, which of the following orbital is an outer orbital complex? Tell me. See, the answer is very simple in this. The reason is all the complexes are how many, what is the coordination number of all the metal atoms here? 6. So we are basically discussing octahedral complexes. And what is the hybridization which we need? And we are talking of out. That means it should be sp3d2. That means the inner d orbital is not being used. Because if you want to use inner orbital, how many you use? 2. Either it is sp3d2 or it is d2sp3. Now let's take the case of cobalt. What is the oxidation state? +3, right? So here there will be availability because this will be a d6 case. So there would be availability of d orbitals. What about iron? +2, again there would be availability. What about manganese? Again. But think about nickel. Nickel is having what configuration? +2, that means d8. So if you do pairing also, then also how many electrons, how many d orbitals are available? Only 1. And if you want to form an octahedral complex, how many d orbitals do you need? 2. So this is clear-cut answer would be nickel, because nickel can't furnish 2 d orbitals for the formation of d2sp3 kind of bond. Is this okay? Next please. Okay. In which of the following coordination entities the magnitude of delta naught will be the maximum? Tell me. In all the cases, the metal is cobalt, right? In all the cases, the charge on cobalt is +3, right? So what is different? The ligands. If the ligands are different, how do ligand affect delta naught? It is their strength. So which is the strongest ligand here? Cyanide is the strongest. So the delta naught would be highest in the case of B. So the answer would be B. Next please. Oh sorry, not next. Next question. CFSE energy for high spin D4. You know what is meaning of high spin? What do you mean by high spin? That none of the electron is being paired. That means the situation is like this. So you have been asked to calculate the CFSE energy. How do you calculate? 3 electrons are in. So what was the energy of this? 3 into minus 0.4, right? 1 electron is in. So 0.6. Okay? This comes out to be minus 1.2 delta naught plus 0.6. So answer comes out to be minus That means the answer is, will you able to solve the questions this way? Right? Next, please. Now, the next important topic is isomerism in coordination compounds, right? There are basically two kinds of isomerism. One is structural, another is stereoisomerism. Structural has four main components: coordination isomerism, ionization isomerism, hydrate, and linkage. Next slide. Next, please. So what is coordination isomerism? Coordination isomerism is nothing but only difference is that there, first of all, for coordination isomerism, there should be an existence of complex anion and complex cation coordination compound. What is important? It will only exist where there is a combination of complex cation and complex anion in a coordination compound, right? Or I can say where the adduct is basically formed by complex cation and a complex anion. So what happens in coordination isomerism? As you can see in the example, here the cobalt, the ligand is ammonia, here it is oxalate. If we interchange the ligands, the metal remains the same. If we interchange the ligands, then what happens? The ligands from the anionic part goes to the cationic part, or from cationic part it goes to the anionic part. We call it coordination isomerism. Is this clear? Next is ionization isomers. Ionization isomers are basically those which are having same empirical formula, but what is the difference between this? This will be having platinum, bromo group, amine group, and nitro. But what is the basic difference here? That when this gets ionized, which ion is going to be there in the solution? Nitrite. And here it would be bromide, right? But these are, because here the nitrite is outside, here it's inside the coordination sphere. Bromide here, bromo group, which is inside the coordination sphere, has gone outside now. So what happens? These kind of complexes are called as ionization isomers. The ionization isomers will always differ in what? They will differ in the ions attached to the metal, and they will always differ in the ions which goes into the solution also. Their metal is here bonded to nitrite and ammonia, here bromo group and ammonia. But when they go into the solution, this will give you nitrite, this will give you bromide. Is it clear? What is the ionization isomer? Next, please. Hydrate isomerism. Any idea what is this? Here, as the name suggests, hydrate, that means water molecule plays a key role. For example, let me take this chromium trichloride 6H2O. Now this H2O, which contain, it may have 4 water molecules, it can have 5 water molecules, it can have 6 water molecules. For example, if you take this complex, what is happening? The chromium, this is empirical formula, right? Here the chromium is bonded to 2 chlorides, 4 water molecules, right? But 2 water molecules and 1 chloride is outside. Here again, what I mean to say is in 3 of these compounds, the only thing which is different is the number of chloride ions and H2O inside and outside the coordination sphere. But when I say inside, and when we say that a particular group is inside the coordination sphere and the same group is outside, that makes a lot of difference. As you can see, when 4 water molecules are inside, the color of the compound is green. And when there are 5, it's gray-green. Or what I can say is these 2 compounds are no more similar. They are totally different compounds. The moment we say that this is outside the coordination sphere, that means that compound, the coordination compound which we are talking about, has drastically changed. There would be change in the every property. Let it be appearance, color, conductance, the kind of ions it will furnish in the solution. Everything is going to be get changed. So hydrate isomerism is basically isomerism which is exhibited when the number of water molecules inside and outside the coordination sphere are different in particular set of compounds, right? Now let's go to linkage isomerism. What do you think is a linkage isomerism? As the name suggests, it has to be linked with the linkage. What kind of linkage? For example, there is NO2 group, which is a nitro group. There are 2 possibilities. The linkage isomerism would only be exhibited by which kind of ligands? Ambidentate. When I say ambidentate means which can donate from more than one coordination site. For example, nitro group here, either it can form a bond to the metal via N. When it is forming a bond with the metal via N, we call it as a nitro group. The other possibility is that it may form a bond with metal from O. Then in that case, we call it as nitrito. Is it okay? Similarly, SCN and NCS, the bond can take from sulfur or it can take it from nitrogen. So if it's bonding it from sulfur, it's a different compound, and from N again it's a different compound, and both the compounds would be called as linkage isomers, right? And let me remind you, the name of the compound also changes. Next please. Now coming to stereoisomerism. What is stereoisomerism? Stereoisomerism is basically related to the spatial arrangement, or how the molecules or atoms are arranged in space around the center metal ion, right? That is what gives rise to stereoisomerism. The very first type is geometrical isomerism. What happens in geometrical isomerism? It is basically how the ligands are placed. The same kind of ligands are they are placed adjacent to each other, or they are placed opposite. When they are placed adjacent, then they are called as cis. I'll take it further. And then trans. And optical isomerism is what? When there are mirror images and those mirror images are not superimposed. I'll take further examples. Next slide, please. Let's take the example of geometrical isomerism in complexes with coordination number 4. Whenever, please remember one thing, tetrahedral complexes, coordination number 4 means either it has to be square planar or it has to be tetrahedral. Tetrahedral complexes will never show geometrical isomerism. For them, their relative positions are always the same, right? Now let's take the example of square planar. Like suppose if I have Ma2X2 kind of compound, right? What is the possibility? For example, here platinum is the central metal ion. What are the ligands? 2 ammonia and 2 chloride, right? Now when both the ammonias are placed adjacent to each other, we call it as a cis isomer. When they are placed opposite, then we say it is a trans isomer, right? Next, please. Square planar complexes. Achha, what is the possibility when all the complexes are different? Suppose the question is being asked that when a metal is bonded to 4 different ligands. Let me tell you, there are only 3 possible structures. And do you know how to draw it? Keep one. Suppose it is MABCD. The trick, how should you draw it? You keep one of them at particular position. Don't change the position of A. B, C, D. Then make another structure. A remains same, but the opposite group changes. Then again, when you draw the structure, A remains here only. So once you got C, then you got B, then now it is. These are the only 3 isomers which are possible for this structure. Next, please. This is again cis and trans, because in this 4 ligands are same and other are 2 different. Like for example, 2 chlorine are lying adjacent to each other. This is a cis isomer where the chlorine groups are right opposite, then they are trans. Next, please. This is very important. It is asked in exams also. One is facial and other is meridional, right? When, like for example, here 3Cl, if they're lying like this, then we call it as a facial isomer. And when they're lying, 2 of them are lying opposite to each other and one is on the plane, then we say it is a meridional, right? Next, please. This is octahedral. Again, this is cis, this is trans. But this I'm taking example of a bidentate ligand. Next, please. This is something, I don't know, it's there in the syllabus or not. These are bridge complexes. As you can see here, Cl are lying on same side and these are also lying on the same. This is a cis isomer. Here, this is a trans isomer. And this would be called asymmetric because there is no symmetry in it as such. Next, please. Optical isomerism. The very first thing which you have to remember is square planar complexes, tetrahedral, octahedral complexes like Ma3, B3, Ma4, B2. They will never show optical isomerism because they have a plane of symmetry. ये compounds optical isomerism show नहीं करेंगे. Next please. The only case which I'm going to discuss is this, right? En is a bidentate ligand. Can you see? This is basically showing bidentate. This is a mirror. The image is this. If you compare this and these both, they are not superimposable. What is superimposable means? You can't keep them one over each. But when you rotate, then they become superimposable. But the mirror images are not superimposable, right? So the mirror images which are not superimposable, they are called as enantiomers. They are called as enantiomers. Next, please. So this is basically I've already talked about. Next, please. Now let's quickly take some questions on isomerism. Which pair of them would be exhibiting same kind of isomerism? What do you think? What can be the answer? What do you think can be the answer? Think about the isomerism we have just talked about. Tell me. What kind of, what is it?
Ionization.
What is this?
Ionization.
But do you think they are going to form a pair? They could have behaved as ionization isomers only when there would have been Br here, but they are different. So this can't be. So what else? Tell me. ठीक है. ठीक है. I'll leave it there. I'll just discuss one of एक linkage का ना discuss. एक ये वाली slide डाल दो. ये वाला नहीं यही वाला slide. हाँ. Now I would like to specially take this example. You know, can you see this example? What kind of isomerism can it exhibit? Because it is having a nitro group, so it can behave as an ambidentate ligand, so linkage, right? Second is this nitride can go out, chloride can come. Then again it is a ionization isomerism. And what is the third kind? Because they are these two and these are four, as I discussed, cis and transform. So it will be showing geometrical. So three kinds of isomerisms would be linkage, ionization, and geometrical. Now I'll go to the next topic, which is called as qualitative analysis. You want me to do qualitative first or environmental? Qualitative, okay. Next slide, please. As you know, in qualitative analysis, basically you have provided with a mixture and you are supposed to detect which anions and which cations are there, right? For basically, what is the preliminary test which you do? One is with dilute H2SO4, other is with conc H2SO4. Carbonate, sulfide, and nitride, they give, you know, test with dilute H2SO4, others give with conc. Next slide, please. Now, the specific test which I want to talk about is chromyl chloride test, right? In this test, what do? Take a U-tube, take a salt, add potassium dichromate and conc H2SO4. Red fumes will evolve, pass it into the U portion, which is having ammonium hydroxide solution, that will turn yellow. And when you add lead acetate and acetic acid, what do you get? You get a yellow precipitate. And that yellow precipitate is of lead chromate. It's of lead chromate. Next, please. Similarly, for iodide and bromide, what you do? You do layer test. In layer test, if you obtain a brown color, then it is basically telling you about the presence of bromide ions. And if you get an violet color, then it is basically confirming the presence of iodide. Next, please. To test sulfite and sulfate, what do? You take water extract, add barium chloride. If you get a precipitate which doesn't dissolve in anything, that's sulfate. If it dissolves, then it is sulfite. Next. A previous slide, what is important factor that how the cationic analysis is being done? The cation analysis is basically based only on one principle that is called as common ion effect, right? Next slide, please. What is a common ion effect? Let me tell you that first. HCl is a strong electrolyte. It dissociates into H plus and Cl minus. H2S is 2H plus sulfide, right? Now, what is Leach-Atelier principle? Le Chatelier principle means always a reaction which is in equilibrium. It wants to be remain in the same state. So what happens if we have these two reactions? This will be strongly dissociating. So number of H plus ions would be more, right? If the number of H plus ions, this is also furnishing H plus ions. Now what will happen? This reaction will move in the backward direction, or you can say the dissociation of H2S would be suppressed by HCl. Why? Because the number of H plus ion should be same, right? So if this is getting more, if you're adding more and more HCl, the number of H plus ions are increasing. If this is increasing, then we don't need this dissociation. This reaction would be pushed in the backward direction so that there is less number of H plus ions. And in that case, there would be less number of sulfide ions also, right? Next, please. So basically, how do we apply common ion effect? Next slide, please. Let me tell you, let me make a quick comparison. You know what is the group reagent for group 2? H2S in acidic medium, and in group 4, H2S in basic medium in presence of ammonium hydroxide, which is alkaline or basic, right? In group 2, this is an acidic medium. This is showing a basic medium, right? What happens in group 2? HCl is strong electrolyte, right? Therefore, when HCl dissociate, it suppresses the dissociation of H2S. So only less number of sulfide ions are being put into this solution, right? So what happens? Those metals which belong to second group, like copper, bismuth and all, which you do the test in second group, only those will form copper sulfide, or you can say only their solubility product would be exceeded. So a particular compound only forms precipitate when its ionic product is when the solubility product becomes more than the ionic product, then the precipitation starts occurring. So यहाँ पे इतनी sulfide ions हो जाती हैं that only the second group is precipitated out. अगर यहाँ ये strong electrolyte use नहीं करेंगे तो there would be lot many of sulfide ions, right? अगर ये ज्यादा होगा तो group 4 का separation भी यही हो जाएगा, because Ksp of group 4 is higher than this and this is low. Second group बहुत low sulfide concentration पे ही हमको product दे देता है, pipette precipitate दे देता है, ये नहीं देता है. When we go to group 4, what happens? Here is a basic medium. This is again a weakly dissociated, but this is giving you OH. OH is combining with this H, forming water. So this H is being consumed to form water. So this reaction is pushed in the forward direction. So now if it is pushed in the forward direction, number of sulfide ions are more. And if they are more, what happens? Now group 4 would be precipitated. So how do we control sulfide here? By using a strong electrolyte. Here we are increasing the sulfide content by using a weak electrolyte. Tick. Next please. Next please. Next. Same as group 3. Again, one is strong, one is that. Because ammonium chloride is basically suppressing the सिर्फ उतने ही OH ion solution में आने देता है जितने की हमको चाहिए. But only those number of OH ions are required, because if the OH ions will increase, what will happen? Again, the group 4 will precipitate as hydroxide. Only that much OH ions are introduced into the solution that only the Ksp of group 3 is exceeded, right? Next, please. Same is here in group 4. Ammonium chloride is suppressing this. This reaction is going backward. Why? Because if the carbonate content will increase, group 6 में कौन है? Magnesium है. अगर हम carbonate content बढ़ जाएगा तो barium, strontium और calcium के साथ even the magnesium will get precipitated in the group 5. So we can't separate magnesium from the 5th group. Right? Next, please. You can go to the next topic, I think. Okay? Environmental. Now let me quickly go to environmental. You know what is environment? Environmental chemistry is a branch of chemistry which deals with the reactions which are taking place in a, what are the sources, how the chemicals are transported, what is the fate of those chemicals, what is the adverse effect of those chemicals, so on, right? Next please. So environmental basically is divided into 4 major components: atmosphere, biosphere, lithosphere and hydrosphere, right? Next please. Again, that atmosphere is further divided into regions like troposphere, stratosphere, mesosphere, thermosphere, and so on. But the 2 layers which are very important for us is troposphere, because where all the vegetation, plants, and animals survive, And stratosphere is important from that point of view that our ozone layer lies in the stratosphere. Next, please. Okay, tropospheric pollution is basically caused by carbon monoxide, hydrocarbons, oxides of nitrogen, sulfur, and particulate matter. Next, please. Let me take 2 minutes here. Ozone layer. You know, ozone layer is a part of stratosphere, right? What happens? O2 absorbs light and gets dissociated into atoms of O, which then combine with O2 to form ozone. What does the ozone do? It absorbs the UV radiation, and then what happens? Again, it breaks, giving out the heat, right? So this heat is basically used to warm the stratosphere. Next, please. Now you have heard about this and you are seeing on TV every day that depletion of ozone layer is taking place. There are mainly two culprits or two depleting agents. One is CFSC, which is chlorofluorocarbons, right? How are they doing it? The sources are basically refrigerating equipments, solvents in plastic industry, which we use, right? What are the chlorofluorocarbon doing? They are in photochemical reaction, they are generating a free radical, right? Chlorine free radical is being generated, which attacks O3 molecule or a ozone molecule. And you can see ultimately at the end, what are we getting? We are again creating more and more chloride free radicals, which will again what? They will destroy the ozone layer. Next, please. And the next culprit, which is depleting the ozone layer, is nitric oxide. How is it doing? You can say NO combines with O3 to give NO2. NO2 again combines with O to give NO. What is important point here is that the NO remains same. We started with NO and we ended up with NO. That means the concentration of NO is remaining same, but ozone is getting depleted. Next, please. Effects of ozone, you know what are the health effects. Next. Now, very important question which is asked in entrance is photochemical smoke and classical smoke. London smoke and Los Angeles smoke, right? Why this is called London smoke? This was observed in London first, and this was first time observed in Los Angeles, right? The classical smoke is basically due to the presence of SO2, whereas photochemical smoke is due to the presence of NO2 and hydrocarbons, right? This is involving smoke and fog. This is the kind of smoke which we see in Gurgaon and Delhi. Classical smoke is the kind which is a combination of smoke and fog, like pollution plus fog is classical smoke. Whereas this kind of smoke, ye misnomer hai. This is not a smoke. It is never a combination of smoke and fog, right? This kab hoti hai? When do we see smoke in Delhi? When the temperature is low in winters generally. Photochemical smoke is observed in afternoons and in summers. Temperature low hona uske liye zaruri nahi hai. The only temperature has to be low for the case of classical smoke. Classical smoke is reducing in nature, whereas this is oxidizing in nature. This is very important from the entrance point of view. Next, please. Classical smoke. What is happening in classical smoke? We have basically oxides of sulfur, which combines with the water vapor, which is existing in the atmosphere to give sulfuric acid. Next, please. In photochemical smoke, we have NO2, and ultimately what NO2 is doing, it is depleting O3, reacting with O3 and giving O2 and O, which is reacting with the hydrocarbons which are present in the nature. And due to that hydrocarbons, what is it creating with by all these reactions? This is called as peroxyacyl nitrate or PAN. And let me tell you, this is not a primary pollutant. This is a secondary pollutant. Secondary pollutant is the one which is being created. Like primary pollutant is this. But this primary pollutant is creating this secondary pollutant, which is called as PAN. And it is also very, it is very dangerous. Next. Now you know about greenhouse effect. What happens? CO2, it absorbs energy, it gets excited, and in this process it collides with other molecules. When it collides with other molecules, it's transferring the heat. So when the heat is, so ultimately what is the result? That the whole atmosphere is being heated up. So what are the greenhouse gases? The greenhouse gases are those which are basically causing the warming of atmosphere, right? Because initially the solar energy is absorbed and then later on it is emitted. Because again, when they re-emit the radiation which they absorb, that causes the warming of the atmosphere. Next, please. Next important topic is acid rain, right? Acid rain is due to the presence of NO and SO2. Both of them react with the water vapor which is present in the atmosphere, giving you nitric acid and sulfuric acid. You know what are the harmful effects? It affects the acidity of water, corrode water pipes. It is also affecting Taj Mahal. It has been long into the discussion. Next, please. Water pollution. When we come to water pollution, we basically talk about the oxygen which is available in water, right? Oxygen gets into water by two ways. First is by direct contact. Second is how aquatic life is doing photosynthesis and absorbing oxygen into it. Next, please. There are two factors, BOD, biochemical oxygen demand, and chemical oxygen demand. What is biochemical? The total amount of oxygen which is consumed by microorganism. Because in water, there are certain microorganisms which are decomposing the organic matter. When they decompose the organic matter, they need some oxygen. And in this process, they are consuming the oxygen and they are depleting the water of its oxygen, due to which the aquatic life do get effective. Because the animals, then they don't get oxygen to breathe. Whereas chemical oxygen demand is something else. It is basically we add potassium dichromate and we calculate how much, pollutants gets oxidized and how much oxygen is being used. That basically gives us idea about the number of pollutants or the concentration of pollutants which is existing inside the water. Next, please. Another important topic is eutrophication. You know what is eutrophication? Usually what happens? There are floods. Nowadays in a crop we use insecticide, pesticides and fertilizers, right? In fertilizers the main component is phosphate. So whenever there is flood or land runoff, what happens? All the water, it goes into the lakes, right? Ultimately, when it goes to the lakes, phosphate is a nutrient for the plants which are existing. So if it's a nutrient for the plant, there would be enough plant growth. तभी आपने देखा होगा lakes with full of water दिखता ही नहीं है, सिर्फ उसके ऊपर plants दिखते हैं. The reason is because phosphate acts as a nutrient for them. And if they get nutrient in high concentration, what will happen to the growth? They will increase. But जब ये ऐसा होता है, what do? When there are more number of plants, what are they going to do? They are going to decrease the dissolved oxygen which is available in the water. They are consuming oxygen, due to which what happens? All the fish or the aquatic life is deprived of the oxygen and they usually die. Next, please. Soil pollution, as you know, fertilizer, insecticides. The only disadvantage or the biggest disadvantage of soil pollution is that it is entering into our trophic levels. Like from soil, it comes to water, water to aquatic life, small fish. Especially, it is affecting those who are non-vegetarians. And now we have observed that it is also started affecting vegetarians also, because it is also getting into vegetation. That's mean plants and trees. Right? Next, please. You want to do some questions on this? Which one of the following is a common component of photochemical smoke? I did it. Peroxyacyl nitrite. Next, please. The chemicals which are present in thermosphere, let me tell you, because I didn't take it specifically. Thermosphere, the temperature is very high. So none of the gases is existing. All the gases, they get transformed into ions. So answer to this is A. All the ions get transformed into cations, right? Eutrophication is due to what I just told you. It is because of the increase in the concentration of it is basically reduction in the concentration of dissolved oxygen in water due to phosphate pollution. Dissolved oxygen kam ho jati hai because plants are consuming. Next, please. London smoke is oxidizing in nature? No, it is not. It was reducing. So this is wrong. Which of the following helps to achieve equilibrium? It is obviously chlorophyll. Photosynthesis is the only way we get oxygen. Next, please. Which of them is a secondary pollutant? Pan, right? Ozone is formed in the upper atmosphere from oxygen by the action of UV rays. Next, please. When rain is accompanied by thunderstorm, the collected rainwater will have pH normal. क्या होगा? Acidic होगा. The reason is जब thunderstorm होता है, in that case जब lightning होती है तो N2 and O2 they combine to form NO, and NO then reacts with water vapors to form nitric acid. So the pH अगर acid होगा तो pH would be lower, right? The brown haze of photochemical smoke is due to NO2, because I told you photochemical smoke is because of NO2 and hydrocarbons. Next, please. Next, please. Now, main component of ozone depletion is a free radical OCl. Next, wait, last, please. The photochemical smoke can be suppressed. In photochemicals, what is being formed? Free radicals. So the answer is radicals. If you throw more free radicals will combine with them and then they'll form stable compounds, right? Next. This is a very usual question. Antarctica, the answer is chlorine nitrate to this, This is the one which is important. It is the cause of depletion of ozone layer in Antarctica. That is chlorine nitrate. This is the last question also, I think. And this is, I'll tell you how to do it. BOD is basically the weight upon the volume. So what is the weight? It is 0.2 divided by what is the volume? 5 liters. So 0.2. But first what we do, we convert 0.2 grams into milligrams. It will come out to be 200 milligrams divided by 5. That will comes out to be 40. So 40 milligrams per liter. 40 milligrams per liter is nothing but it is 40 ppm. Because ppm is nothing but milligrams per liter. 40 ppm means there are 40 milligrams of a particular substance in 1 liter of a volume. Is this clear? Next.